Good morning, everyone. Welcome to today's hearing. Today we're going to hear evidence from Professor Jose Torero, one of the experts appointed to assist the inquiry. Yes, Mr. Millett.
Good morning, Mr. Chairman. Morning, members of the panel. I now call, please, Professor Jose Torero.
Thank you. Good morning, Professor.
Morning.
I understand you're going to make the affirmation.
Yes.
So could I ask you please to read out the words on the screen?
Yes. I do solemnly, sincerely, and truly declare and affirm that the evidence I shall give shall be the truth, the whole truth, and nothing but the truth.
Thank you very much indeed. Would you like to sit down?
Thank you very much.
Make yourself comfortable there. Yes, Mr. Millett, when you're ready.
Chairman, thank you. Good morning, Professor.
Good morning.
Can I start, please, by asking you to state your full name for the record?
Jose Luis Torero Cullen.
Thank you. Now, I should also start by thanking you very much indeed for coming to the inquiry and assisting us with your expert opinions, both in your reports and your oral evidence that you're going to give us today. You've given us two reports for the purposes of this phase 2 so far. And am I right that those reports essentially consider the correlation between the fire safety strategy for Grenfell Tower and the various aspects of the adequacy of the LFB's procedures and training?
Yes.
Yes. Now, the first of those reports is at JTOR 702. Can we please have that up? That, as you can see, is dated the 21st of April 2021. Is that your signature?
Yes.
Thank you. And have you read this report recently?
Yes.
Thank you. Can we go to the second of your Phase 2 reports, please? JTO 705. And that is dated the 15th of August 2021. And again, is that your signature on that page in front of us? And have you read that report recently?
Yes.
Is it right that your second report, the one on the screen, contains what you call further considerations on the presumption of technical competency?
Yes.
And does that build on the general analysis that you propounded in your first report and consider some of the analysis provided respectively by Professor Christopher Johnson on incident ground communications and Steve McGurk in relation to matters of operational firefighting procedures and training?
Yes.
It does. And I think I'm also right in saying that you have considered some of the opinions of Professor Ivan Stoyanov in relation to water supply on the night of the fire.
Yes.
We will not be exploring those matters with you today, I should tell you. Can you, subject to those things, can you confirm that the facts and matters set out in each of those reports are true to the best of your knowledge and belief?
I can confirm that.
And that the opinions set out there are your true and honestly held professional opinions?
Yes.
And is it right that you've provided the experts' reports to the inquiry in the same way that you would have provided an expert report or reports to the court?
Yes, I did.
The English court, that is. Yes. And am I right that your opinions on the matters that are relevant to phase 2 of the inquiry thus far relate to the matters we've discussed, the adequacy of the LFB's training and procedures, so far as they informed the operational response of the LFB on the night?
Yes.
Now, to be clear, and just to set it in context, the reports that you provided for phase 2 of these investigations are further to and build to some extent on the initial report, the updated report and the addendum that you provided to the inquiry for the purposes of its phase 1 investigations. Is that right?
Yes, I do.
Yes. Now, your phase 2 reports, I think, also build on the findings and recommendations provided following the in the phase 1 report itself.
Yes.
Building on what you provided to the inquiry for that purpose.
Yes, I do.
Yes. Now, can I then look at your experience and qualifications? I think I can take this quite quickly because you have set out your background and your fields of expertise on pages 8 to 10 of your first report at section 1.4. We could have that on the screen so that people know where to find it. But can I touch on some specific points identified there so that those watching can understand some of the basics? First, and correct me if I'm wrong about any of this, you specialise in fire safety and you've worked in that field for more than 24 years, having originally trained as a mechanical engineer and then gone on to obtain a PhD with a specialisation in fire safety.
Yes.
And you're a chartered engineer by the Engineering Council Division of the Institute of Fire Engineers in the United Kingdom.
Yes.
also a registered professional engineer in Queensland, and a full member of the Society of Fire Protection Engineers in the United States.
Yes.
Also a fellow of a number of engineering schools and institutions, both here in the United Kingdom and abroad.
Yes.
And you were awarded the Arthur B. Guise Medal in 2008 by the Society of Fire Protection Engineers in the United States.
Yes.
And in 2011, the David Rasbash Medal by the Institution of Fire Engineers in the United Kingdom in recognition of your eminent achievement in the education, engineering and science of fire safety.
Yes.
And currently, you are Professor of Civil Engineering and Head of Department of Civil, Civil Environmental and Geomatic Engineering at UCL, University
Yes.
College London. And before that, you had held the John L. Bryan Chair at the Department of Fire Protection Engineering, and you were the Director of the Centre for Disaster Resilience at the Department of Civil Engineering at the University of Maryland in the United States, yes?
Yes, that's correct.
And before that, Professor of Civil Engineering and Head of the School of Civil Engineering in the University of Queensland in Australia between 2012 and 2017.
Yes.
And before that, you held the Landolt and Company Chair for Innovation for a Sustainable Future at the École Polytechnique Fédérale de Lausanne in Switzerland in 2012.
Yes.
And also, we will come to the end of this quite soon, but also the BRE Trust Royal Academy Engineering Chair in Fire Safety at the University of Edinburgh between 2004 and 2011.
That's correct.
Editor-in-Chief of the Fire Safety Journal 2010 to 2016.
Yes.
And that's a very respected journal in this field, isn't it?
It's a leading journal.
It's a leading journal, and you've been an editor on a number of other academic publications and journals too.
Yes.
And involved in a number of fire investigations, including between 2001 and 2011 into the World Trade Center buildings 1 and 2 collapses.
Yes.
And you've done dispersion fire modelling, supporting the litigation relating to Buncefield, the Buncefield explosion, and the Seago mine explosion in the United States.
Yes.
And also, I think you conducted the post-fire structural assessment of the Abu Dhabi Plaza fire in Kazakhstan.
Yes.
Which I think you say is the biggest ever fire of a building under construction.
Yes.
And you've developed training programs on investigation for fire and rescue services in the United Kingdom.
Yes.
Taught courses for fire and rescue services in many different countries across the world, and developed curricula and taught fire engineering courses at a number of universities,
Yes.
including those we've looked at, but not exclusively so. And also in the United Kingdom, I think it's right that between 2007 and 2010 you led the development of the Fire Grid project, funded by the Department for Trade and Industry, as it was then called, which involved a detailed study into the role of information in fire brigade emergency responses.
Yes.
And that project, I think, concerned, very much in summary, the use of, and specifically the use of information in order to predict how a fire is likely to behave at an incident.
That's correct.
And you've also acted, and this is finally, in numerous advisory roles, both for government and industry in the United Kingdom and abroad, including the fire service.
Yes.
And at the time of these Phase 2 reports, I think, is it right, you were acting as special advisor to the Minister of Housing in Queensland, Australia, in relation to facade fires.
Yes.
Thank you. I want to touch just on the scope of your of what we're going to discuss today. When you refer to the fire safety strategy for Grenfell Tower, I'd like just to clarify what you mean. You've told us that you aren't referring to any specific document that might have been produced in relation to the tower. Is that right?
Yes.
And I think, is it right that you're using the term fire safety strategy to refer to the collection of measures that are implemented in order to ensure fire safety in high-rise buildings?
Yes.
I see. And also that firefighting operational protocols are an integral part of the fire safety strategy itself.
Absolutely.
Now, I want to address really 4 issues with you that arise from your 2 reports in this Phase 2. First, what you refer to as design fires and the significance of building performance in the context of increasingly complex modern structures. So, design fires. Second, I want to ask you about what you refer to as the societal expectations and presumed competency of the fire service to deal with fires in that context. Third, the significance of the dynamic risk assessment, which you, I think, identify as the means by which fire services are able to respond to unexpected fire and building behaviour. Yes?
Yes.
And fourth, I'm going to ask you about the operational response to the fire at Grenfell Tower on the night of the 14th of June 2017.
Yes.
Now, against that background, and apologies in advance for presenting you with the risk of oversimplification, can we reduce your opinions to three basic theses? First, that fire brigades regularly and wrongly assume that the building in front of them is compliant with regulation when it isn't.
That's a difficult question to answer while postulated in those terms, but they do regularly make that assumption. Whether it is wrongly or not depends on whether the building is compliant or not with the building regulations. But I agree, they will assume that when they arrive to a scene of a fire, that building is compliant with the building regulations.
When I say unwrongly, then what I think I mean is unsafely.
Potentially.
Yes. Second, that modern fire brigades need to have the technical competence at all levels necessary and sufficient to be able to put out fires and save life in all buildings, regardless of their complexity and their regulatory deficiencies.
That's what they are there for.
Third, technical competence requires a technical understanding at all levels of the construction methods and materials used in any particular building, that building's layout, and how it presents risk and how it will aid or hinder effective firefighting and rescue operations.
Yeah, that statement is correct. But again, it needs to be caveated with what is the definition of technical competency and who will have which level of technical competency within the hierarchy of the fire brigades.
Subject to those caveats, are we able to reduce your opinions further to a single proposition, and again, at risk of oversimplification, that you say that the design and the construction of buildings and the work of fire brigades are inextricably interlocked as a singularity, but neither legislation, regulation, nor professional standards and attitudes in the United Kingdom Fire and Rescue Services see it like that?
I agree.
And am I also right that you consider that neither society at large nor the LFB in particular consider that fire and rescue services are an integral part of fire safety strategy as you define it?
That is correct, but once again, it goes back to the problem of the definition. There is an expectation of the fire and rescue services in regards to their role the moment they arrive on a fire scene. And that expectation in principle responds to what you just said. Nevertheless, how do you define those terms can be quite complicated.
Yes. And is it your view that neither society at large, for which perhaps they could be forgiven, but fire and rescue services in particular do not understand the degree of competence required for an incident commander to perform a dynamic risk assessment in the case of a building design failure?
I would agree with that.
And your solution for that fundamental problem is, in summary, what?
That there has to be a very clear respect for the role that technical competency has in the activities that a fire brigade is expected to perform.
Yes. Now, can I turn to the first of the topics I identified for you a few moments ago, that is design fires and modern construction. Can I ask you to look at your first Phase 2 report, please, JTOR 702, page 12. Let's look at lines 434 to 435. You say there, to fully establish the need for a fire and rescue service to evolve, it is first essential to discuss the relationship between firefighting and the provision of building performance in the design process and beyond.
Apologies, but I think I'm not getting the...
No, I was just about to say, I think we're looking at a different part, aren't we?
We are.
Yes.
We're looking
Yes.
at... Yes, no. I said 2. In fact, we're looking at the separate report, and I'm quoting. if we go to page 12 of 2,
That looks more like it.
that is it. I'll read it to you again. It's 434. To fully establish the need for fire and rescue service to evolve, it is first essential to discuss the relationship between firefighting and the provision of building performance in the design process and beyond. Would it be right to say that the point you're making here is that it's crucial to consider the function and performance of the fire and rescue service in the context of how buildings are designed?
Yes.
And that's because, is it, that the level of competence that's necessary for the fire and rescue service to demonstrate is directly related to the design of the building?
Absolutely. If you have a building that requires for the fire brigades to have a very, very high level of competency, then that has to be made very clear from the onset, because that is the job they're coming to perform. If you have a building that requires much less level of competency, then that has to be made very clear so that they understand what is the job they came to perform.
Yes. And you go on to say at lines 436 and 437, currently building and infrastructure development in the broad sense is conducted through design principles that are based on a series of fundamental assumptions and are executed via a range of design tools. Can you explain here what you mean by a series of fundamental assumptions?
Yes, absolutely. So if we take as an example approved document B. So approved document B has two parts. It has guidance and it has the building regulations as they pertain, for example, in the case of facades, the functional requirements like B4. So in principle, that gives you the way in which you are executing the plan. But what approved document B doesn't give you is the problem formulation or the plan formulation, which is it never requires you to perform an adequate fire safety strategy. That fire safety strategy is going to determine how all the bits and pieces fit together and how you're utilizing the functionality requirements and how you're utilizing the guidance or any other tools to meet the requirements of the building regulations. The assumption that is embedded in the documentation that we have that regiments the way in which we design buildings is that somebody will create that fire safety strategy. It is not required, it is not part of the process. There is a core assumption that somebody is creating that fire safety strategy, and that fire safety strategy has to include the role and definition of competencies of the fire brigade they expect to respond to an event in that building.
Right. I mean, who is it assumed will perform the role of creating a fire safety strategy?
The creation of the fire safety strategy, formulation of the problem, in principle, should be done by a fire engineer and by the designer of the building in accordance with the other stakeholders, which obviously includes the fire brigades, because the fire brigades their working place is going to be the building in the event of a fire.
Now, if we go to line 437, where we've just been looking, and look at the next sentence, you go on to say, the design can either be regulated by compliance with codes/standards or by explicit demonstration of adequate performance via professional/technical analysis engineering. The design is then implemented and the building is assumed to provide adequate performance, including delivering societally acceptable levels of fire safety. Now, is what you're saying there that once a building has been shown to be compliant with the relevant codes and standards at the design stage, it is assumed by fire and rescue services, those services responsible for the building in which the area in which they are responsible sits, that the building will perform in accordance with that design in the event of a fire?
That is correct the day of the handover of the building, but buildings are living entities and they're going to evolve in time and users are going to use them in different ways. So in principle, this is why we introduce what we call a feedback loop. In other words, the inspections and fire risk assessments and so forth that come afterwards, so that we can guarantee that that building continues to perform as designed. Now, the assumption that the building was designed according to the adequate performance requirements at the day of the incorporation of the building into the system, it's a correct assumption.
You say it's a correct assumption. Is it a safe assumption?
Well, that really, well, I mean, it depends on how well the process works. Now, obviously, if you're operating on the principles of functionality requirements, then there has to be an explicit demonstration that safety has been attained. And that explicit demonstration has to be agreed by other stakeholders, including the fire brigades.
And going back to your feedback loop, as you put it a moment ago, where you say that inspections and fire risk assessments and so forth that come after design and construction, so that you can guarantee that the building continues to perform as designed. Does that tell us that those conducting the inspections and fire risk assessments need to have at least a reasonable grasp of how the building was designed, at least in relation to its fire safety performance?
Most definitely, because in many ways what they're looking for is if the building has evolved in a way such that might lead, to an unsafe situation. And for that, you need to really understand what the limits of the provisions are. So just to give you an example, if I put a sprinkler system, and the sprinkler system is designed for an office space like this one, but I decide to convert this place into a warehouse, and I start putting boxes that go all the way to the ceiling. Whoever inspects that has to be able to recognize that the sprinkler system was designed on a series of assumptions and limitations that requires the building to have chairs and desks and cannot have storage racks. So that level of competency is essential in the process of an inspection, because otherwise you will end up missing the details. Now, there's another aspect that is very important about inspections, is that, as I say, things are not static. And as we progress, we learn. And many times, through either disasters or through events, we start figuring out that there are certain problems and certain things that we had presumed that were actually safe. All of a sudden, we start realizing that technology has evolved in a way such that we're introducing things that might actually not be safe. So we need to have the presence of mind and the competency to be able to identify when those things have penetrated, and they were unnoticed. And at that point, you need to highlight the fact that those things might have an impact on the safety of the building, on the safety of firefighting operations, and on the capability to deliver the job.
Yes. Can we go, please, to page 13, the next page in this document, and look at lines 466 to 468 together? At 466, you say this: in respect to most fire safety provisions, ongoing performance assessment is indirect and therefore not truly quantified beyond the design process. It is assumed that if a provision introduced through the design process remains unaltered, then performance should be as dictated by the design. Now, can you just clarify for us what you mean here, particularly in relation to what you mean by indirect? Ongoing performance assessment is indirect and therefore not truly quantified.
Yeah, just to give you an example to illustrate that. So, for example, these columns there will be an expectation that they have a certain fire resistance, and that fire resistance was embedded into the column during the process of design. So, unless I have something that evidences the possibility that the columns might not be performing appropriately, for example, a big crack or a missing piece of plasterboard, I will make the assumption that this column still retains the fire resistance with which it was designed. And I don't have any direct means to demonstrate that. That's why it's indirect, because I cannot pick up the column, bring it to a furnace, and test it for fire resistance and then put it back. So in principle, I just simply have to rely on this indirect means to achieve the objective.
Yes, I follow. Now, you go on, I think, to discuss the relationship between building design and firefighting activity in a number of different places here. But if we look at line 472, you say this: it is in the design process where provisions are made to support firefighting activities, and these are based on preconceived modes of operation or known policy. Now, just to be clear, when you're referring here to preconceived modes of operation or known policy, are you referring to preconceived firefighting modes of operation and known firefighting policy?
Yes. So just to give you an example, you will put in a building a certain set of water supply systems, and those water supply systems have to be consistent with the tools the firefighters will bring in, to use the water in the building. So basically you have a clear idea of what are the list of things that the firefighters will need to perform their job, and in the design process you're supposed to embed those, and the fire brigades are supposed to make sure that they have everything that they need to conduct their operations.
I follow. So would one simple example be a dry rising main?
Exactly.
Yes. Now then you go on to say from the middle of line 473, thus the design process will deliver a building where the fires that can occur, and you call them design fires, are only those that can be fought using existing protocols, which you call operational protocol. Now, you use the word design fires. There's a footnote which we can have up on the screen if the page can be scrolled down, footnote 16, and you say there, the term design fire is commonly used by fire safety engineers and not by fire and rescue services when referring to operations. Nevertheless, the meaning, i.e. a fire event of sufficiently high probability, applies both to the design of a fire safety strategy or operational protocols for firefighter response that are an integral part of such a strategy. Does that tell us that when buildings are designed, it is intended that any fire, or should be intended, that any fire event that may occur will be capable of being fought using existing established operational firefighting procedures?
Yes, that's correct.
In other words, the predicted operational response will be designed in.
Yes, so in principle, you are designing all the necessary provisions, and those necessary provisions will lead under most circumstances, to a condition that is consistent with the condition that the fire brigade would expect upon arrival to the fire scene.
Yes. Now, just breaking that up a bit, does it mean first that conversely, the operational firefighting protocols that are developed by the fire and rescue services will be developed on the footing that they'll be effective in dealing with a fire in a building because the building has been designed specifically with those firefighting procedures in mind?
Yes, that's what would be correct.
Yes, and also that there's in a sense, a reciprocal reliance by both building designers and fire and rescue services in that context.
Yes, they're inextricably coupled. There is no way to separate the two of them.
So to make the point perhaps a bit clearer, do you agree that building designers would rely on the fire and rescue service to be able to implement existing operational protocol in the event of a fire, and the fire and rescue service rely on building designers to design a building that is capable of being fought applying existing operational protocol?
Exactly.
Yes.
And just help me with this, would it also be right to understand that designers of buildings have in mind a certain range of fires which are likely to occur, for which the building, so to speak, is designed to respond, but it's not an unlimited range of fires? Perhaps it is, I don't know.
Yeah, no, that is correct. I think you put the necessary provisions in such a way that you bound the possible fires to things or to events that you can actually manage appropriately. Yeah. So it is not an infinite number of fires. Now, this is it's a very, very good question, because I think this is a matter of great confusion when people say that fires are unpredictable and they can go in all directions. Fires, it is true, if you look at it at a very refined grade and try to, for example, predict, to the millimeter or to the millisecond the progression of a fire, the fire can be treated as almost a random event. But the reality is that, nevertheless, when you start looking at the design level, you make things a little bit coarser. So you become a bit more conservative, you put safety factors, you work your way in a way such that you bound the event to a space where you know that it cannot exceed a certain maximum temperature, it cannot exceed a certain maximum volume. And so you create an event that will maybe random, in its highest fidelity, it is actually perfectly predictable, in its broad, representation.
Thank you.
Yes. Now, in relation to this mutual reliance on each other by the fire and rescue service and the building designer, respectively, I think that's what you refer to as the two-way link in line 76. What do you contemplate in particular would be included in the operational protocol?
Can you expand a little bit so I can understand better what you mean?
Well, you use the expression at lines 4, 7, 4 to 6, operational protocol, which is about firefighting using existing protocols. What do you contemplate should be included in an operational protocol, given the mutuality of the relationship with the designer?
There's a multiplicity of things. There's going to be the sort of active event of fighting the fire. So you have to really understand what resources you have available, the competency capacity of those resources. You have to understand the structure under which they operate. You will have to understand the tools that they have available, and you will have to understand the capacity. So just to give you a simple example, if you have a very, very large warehouse that is filled up with expanded polystyrene, you will not expect the fire brigades to have the capacity to fight a fire of that nature. So in that case, you're designing for a total loss, and all that you're guaranteeing is that life safety is preserved. And in that case, for example, because you recognize that the protocols, everything that the fire service has, is not capable of delivering the control of the fire, then you just have to expect a total loss. And you design for it.
Right. Taking a sort of a slightly sideways look at that, would you expect a designer to take into account absence of competence within a fire and rescue service when confronted with a particular building design feature?
No, and this is a presumption of competency.
Right.
So you are presuming that the skills that the firefighters in principle are supposed to have to be able to do their job are all present at the moment they will arrive to the scene.
So just simplifying it, and again, at risk of overdoing so, you wouldn't expect a building designer or a refurbishment designer to say, well, I'm not going to do that to the building, because if I do that, then the local fire and rescue service won't have a clue about what to do with it if it burns.
There's the theory and there's the practice. So in theory, absolutely, what you said is correct. But the reality is that as a designer, you also have the onus to introduce robustness into your building. And if you have too heavy of a reliance on the fire service, you might end up in a situation where you are putting too much weight on a presumed level of competency that you probably cannot guarantee. So you have the onus of putting robustness into your design.
Yes, I see. Now, can we then look a little bit lower down the page, at line 488? You say there that this limited range of outcomes, I'll start at the beginning, it's probably easier. As explained above, the implementation of an appropriate feedback loop is of particular importance in fire safety, because design decisions are intended to limit the range of outcomes of a fire. This limited range of outcomes enables fire and rescue services to define a specific range of response protocols which responders can be trained to carry out efficiently and safely. Can you just explain what you mean there?
Yes. So if you are going to perform a task, you have to understand what that task is. So if I basically do not narrow down the potential of a fire to a series of events that can be defined as the task, then the fire brigades cannot develop a series of protocols that can actually perform the task.
When you say if you're going to perform a task, are you referring to the designer or the firefighter?
I'm referring to the fire brigades.
Right.
So the task of the fire brigades is basically to come in and take a role within the fire safety strategy. And that role is to, in the event that there is a design failure, then the firefighters are there to try to control the event and bring it to a level that is an acceptable level of safety. That is the task.
Yes, I see. Does it follow from that if the fire and rescue service proceeds on the basis that only design fires will ever occur, the nature and extent of operational procedures and training that need to be developed is relatively limited?
Well, it could potentially be. So if the window of potential events that you have, like like it used to be in sort of the very compartmentalized old residential type of buildings, then fundamentally you have a very narrow set of events that could possibly happen. And because you have a very narrow set of events that could possibly happen, you could focus your training and education into those events.
So if a fire and rescue service were only ever dealing with design fires, then they wouldn't need to have any knowledge, would they, or any insight into building behaviour, because they could always trust the design to support their firefighting.
That is completely correct if you ignore what their fundamental role is. They are the ultimate redundancy. So in principle, they are part of the fire safety strategy as the ultimate redundancy. So you can, if you assume that a building is always going to perform as designed, then there will be no need for fire intervention. But we know very well that we have human factors, we have a number of different issues that need to be addressed, we have deterioration of buildings, we even have design mistakes, and therefore you introduce this ultimate redundancy to your system, to your fire safety strategy, that enables you to pick up the pieces when something doesn't go right.
I see. So does that mean that if the fire and rescue service limit their training and preparation to what you call design fires, then they can't deal with undesigned fires? In other words, fires that happen despite the design.
This is why they need to be trained on this concept of the dynamic risk assessment, because at some point they will have to make an assessment if the event has departed from the design fire and then introduce alternative ways of confronting the problem.
Yes, and I think you go on to say, in the previous paragraph, you say, and I'll summarise, you say essentially you can't offer infallible guarantees that all fires will be as anticipated. Therefore, you say at 484, fire and rescue services have to possess a means to provide an adequate response to events that differ from the design fire. The dynamic risk assessment is the most common means to achieve this. And when you say behave as anticipated, do you mean a design fire? As designed, yeah. Yes, I see. And you refer to the dynamic risk assessment there. We're going to come to that later, but for the moment, can you just explain in brief terms, if you can, what a dynamic risk assessment is?
In conceptual terms, a dynamic risk assessment is you take the information that is available to you, and on the basis of that information, you make an assessment. And that assessment might either confirm that your procedures and protocols are operating correctly, or it might lead you to believe that you actually have to alter the product, the process. So in a way, that continuous evaluation of the event is what the dynamic risk assessment is the usage of the information that you have available to inform your decision making.
Yes, and of course we know there was a policy for that. I think policy 342, revised as current in August 2016, for the London Fire Brigade.
Yes, that's correct.
Yes. Now we'll come to dynamic risk assessments a little bit more closely later. But you've explained that the ability to carry out an effective dynamic risk assessment depends on the fire and rescue service having obtained sufficient and relevant information about the building before a fire occurs. Is that right?
Your dynamic risk assessment is only going to be as good as the information that you have. So if you don't have adequate information on the building, its fabric, and its characteristics, it is very clear that you're missing a big part of the picture. So the quality of your dynamic risk assessment will deteriorate in the absence of that type of information.
And the information you're referring to, would that ordinarily be collected under Section 7.2D of the 2004 Act?
Yes, so that will be one of the means by which you collect that information.
Yes. Yes, and another means would be what?
I mean, it varies in different parts of the world. In some places, for example, you have continuous assessment of fire hydrants, and so fire brigades will come in on a regular basis and evaluate the fire hydrants in different areas and make sure that they're operating correctly. In other cases, there is processes by which you are required to report information on buildings by the building managers that are constantly coming to the fire services. There's many ways by which you can acquire the information, but in the UK, is through that process of inspection, the main way by which you acquire the information.
Are we able to add to that, and maybe add is the wrong word in this context, but the information gleaned by fire and rescue services as either inspecting bodies or enforcing bodies under the regulatory reform order?
Yes.
Yes, which would depend heavily on the building owner or the responsible person having the information in the first place.
Exactly.
Now, we'll come to that question, I think, later. But in summary, if you look at line 495 over on page 14, you say this. You say at the end of the line, it is important to note that as the complexity of the building and its fire protection systems increases, the degree of competency required of those gathering the information inevitably increases. Now, when you say degree of competency increases, do you mean that, or do you mean that they would need to become competent at new or more complex things, not more competent at things they already know about?
Well, both.
Both.
I think that if any professional practice is due to keep up, with the technology as it's coming in, and as such, you have to expand your competency into areas that become relevant to you, but at the same time, refining your knowledge on areas where you were already deemed to be competent is always an appropriate course of action. Is continuous learning, basically.
So, does that mean that those responsible for collecting information by whatever source or from whatever source need to acquire new skills and experience commensurate with the innovation and increased complexity of buildings?
Not only those collecting the information, but everybody who manages that approach. Because there's many ways, as you said, of collecting that information, and a lot of that information comes internally. So you will have individuals that are a higher management level that will be acquiring information from other events, from other institutions, and it's their responsibility to make sure that the information is transferred to those conducting the inspection. So basically you're collecting inspection, but the competency has also to be informed by information that is being collected by the organization in itself as a whole.
And that would filter down the levels to firefighting.
Absolutely.
That was a question, but you agree with the proposition.
Yes.
Going back to the notion of design fire, if we can, Professor, you refer to the beginning of the fire, the outset of the fire on the 14th of June 2017, namely the kitchen fire in flat 16 on floor 4 of Grenfell Tower, as a very high probability event for a building of that nature. And that's on page 14 at line 520. We can just scroll down to that. It's at the bottom of your screen. But you go on to say, from the end of line 520, this. You say the expected performance, i.e. the design fire, was such that such a fire would remain within the unit of origin, and therefore flames and smoke would not compromise other units. The compartmentalisation recommended by government issued guidance aims to contain the fire within the unit of origin and thus allows implementation of what is called a stay-put strategy. Now, would it be right to say that the stay-put strategy or policy is an example of a fire safety strategy premised on the design of the building?
The stay-put strategy is one component of the overall fire safety strategy. That's a component that leads, with the evacuation or egress practices. So in this particular case, you are making the decision that people will remain in place, and you put all sorts of other provisions around it, and that represents the fire safety strategy. That will make sure that people will stay in the building and they will remain safe.
I see. So just to be clear, it's not a strategy that is imposed from outside on an existing design. It is a strategy that is designed for.
Yes, it is a choice. So you choose a stay-put strategy, and as a function of that, you put adequate provisions to support a stay-put strategy, including the provisions necessary for the fire brigades.
And forgive the simplicity of the next question, but would it be right to say, therefore, that stay-put is reliant on the building performing as expected in the event of a fire? In other words, it's appropriate in the context of a design fire, but not otherwise.
Exactly.
Now, you refer at lines 530 on the next page, please, page 15, and line 531, to some statistics on the frequency of high-rise fires requiring generalised evacuation. I think you're referring here to Colin Todd's Phase 1 report to the inquiry.
Yes, that's correct.
Now, you will go on. You say there that one of the statistics is that more than 8,000 fires in high-rises in the UK in the last 20 years, only 2 cases justified generalised evacuation. And again, you refer to Colin Todd's statement. Am I right that, in fact, I think that's a typographical error, because his report refers to 22 cases that required evacuation of more than 5 people in over 8,000 fires in blocks of flats?
That's correct. Apologies for that. It's somehow the 20 disappeared.
Okay, so it's 22. But the point you're making, is it right, despite that error remains the same, but before the Grenfell Tower fire, the statistics showed that only an extremely small proportion of fires in residential high-rise buildings resulted in some form of evacuation?
Yes.
So would it be right to say, looking at it objectively, that they were statistically insignificant?
Yes, there is. That is correct. There is 2 ways always to look at this type of problems. One of them is looking at the past, and that's where the past statistics reinforce your position. And the other one is looking at the evolution of things. And in parallel, what you have is an increased awareness of these large-scale fires that were effectively breaking the compartmentation and potentially requiring a full evacuation. So you have, in this case, the 2 things going in parallel, but it is correct that if you use the approach of looking at past statistics as a reference of what you're doing, then effectively this will reinforce the position that fires will remain in the unit of origin.
Yes, of course. I imagine that looking at the statistics for the past is very valuable so long as you haven't changed your practices for the future.
Exactly, and this is why you have to look at both.
Yeah.
What do those statistics tell you about the risk of a fire requiring evacuation by way of departure from stay put in any particular building?
Unfortunately, very little.
What do they tell you? They may tell you about frequency risk, but do they tell you about severity risk?
No, the reality is the risk is always defined by the probability multiplied by the consequence. And this is one of those cases where if that component failed, then the consequences are massive, and you cannot ignore the potential of the consequences, even if the probability is small.
Yes. Now, in his Phase 2 witness statement, Commissioner Rowe, Andy Rowe, has told us that, to the best of his knowledge, the Grenfell Tower fire represented the first departure from the standard stay-put strategy in England and Wales. Is that consistent with your understanding?
No, I think that again, I think many times we use language in very different ways, and many times we use the same type of words and mean completely different things. I think the question for me is when the problem is that when you look at past statistics, you have to really be careful in the way in which you take the information, and also what information is available to you, because at the end, what you really want to understand is whether a stay-put strategy should have remained, not whether it was done or not, because you might have been in many very near misses, and those don't get recorded. So the way in which we collect the statistics define the way in which we think. And unfortunately, because we are not collecting the near misses, then we're missing all these cases where we had all the alarm bells and all the warnings, that were telling us that we were going in a certain direction, but because we didn't take the action of going to a full evacuation, then it got recorded as a success and not as a near miss.
Yes. Yes. Now, can we look at 531? You say, thus a strong perception that building regulations support the operational protocols of the fire and rescue services is backed by statistical confidence. Now, when you say statistical confidence, are you endorsing the statistical confidence, or are you observing that others have statistical consequence because of the numbers?
No, I'm definitely not endorsing the statistical confidence, because, as I say, This is where the competency comes in. If you are seeing what is happening and you're looking at how things are evolving and how our practices are changing, we cannot look at the past, because we know that the buildings that we were designing 30 years ago are completely different to the buildings that we are designing today.
And going back to the point we discussed a moment ago about frequency risk and severity risk, would you agree with this, that in relation to statistical confidence, there is a risk of conflating the apparent rarity of an event, so a fire behaving in a way that's inconsistent with building design, for example, by breaching compartmentation or bypassing it, on the one hand, with the level of risk that's presented should that event come to pass?
Yeah, I mean, that's really the problem. I tried to describe that in my phase 1 report, where I basically showed that the severity or the potential consequences of this particular form of failure were so large in magnitude that they had to be treated in a very careful way, because they unzipped every element of the fire safety strategy. So in a way, when we look at Grenfell and we look at Grenfell as a failure event and we identify all the things that failed, what we should never forget is why they failed. And the reason why they failed is because we lost compartmentation. So we disabled the fire service, we disabled the other measures of compartmentation, we disabled the doors, we relied too much on self-closers. All these things are a chain of events that is generated by a single point failure that was capable of creating massive consequences.
And just exploring that a little bit more, does it tell us that, or would you agree, that the fact that an event is rare and therefore unlikely, even statistically insignificantly likely, tells you nothing about its potential severity in the 5% of cases?
You need much more information to be able to assess severity. That's not sufficient information to make that statement.
And so statistical confidence leads, may it, to the mistaken assurance that because an event doesn't happen often, or happens so infrequently as to be statistically insignificant, it poses a low risk.
Reliance purely on statistics and not using all the other available information is actually a measure of lack of competency.
And does that mean that if an event is rare to the extent demonstrated or deducible from these statistics, but has a very high risk of severe harm if it happens, there's a greater need to prepare for it?
Absolutely.
Because the operational personnel who are responding to the event when it does occur are less likely to have any direct prior experience of it.
Absolutely.
Right. And in your experience of working with fire and rescue services before the Grenfell Tower fire, and in particular in relation to operational training, would you say that you observed any statistical confidence on the part of those organisations you worked with? In other words, they relied on what you've referred to as statistical confidence.
There's a very significant reliance on statistics. I mean, the declining events, the declining fire deaths, all these things are constantly being used in support of current practices.
Yes. Now, when you say in line 531 here that there is a strong perception that building regulations support the operational protocols backed by statistical significance, confidence, who is it who had that strong perception? Whose strong perception is it?
Everybody's.
Everybody but you.
Well, I mean, I think this is really the one of the problems that we always tend to face is like when you're dealing with events like fire and fire provisions that require investment and require effort in the design process and so forth. The easiest thing to do is fundamentally back yourself up with the fact that those events are not happening. So people use the fact that we have declining fire events, that we have declining fire deaths, that we just basically to support all our practices. It's not only the fire brigades, but it is the way in which we design, the documents that we use, the policies that we implement. Everything is backed by the fact it's not going to happen to me.
Yes. I mean, the answer, everybody, slightly troubles me because I rather thought you were excluding those people who knew something about fire engineering.
Well, this is what happens, so that you're going to have a conflict between those individuals who actually understand the problem, understand the complexity of the problem and the magnitude of the problem, trying to tell you that you need to put all these provisions in place. Now, when you create that conflict, you are creating an unavoidable crash, because what ends up happening is that in a market in which you have to make decisions of who you're going to employ, you're going to basically employ the people who are going to give you the answers that you want for the minimum cost. So if I'm working with an architect, the best possible answer I can give an architect is don't change anything. The moment I start saying you have to change this, you have to improve this, you have to fix this, very rapidly what ends up happening is I'm becoming, the nasty person that is ruining everything. Now, on top of that, they have to pay me for it. Okay, so if you are in that situation, eventually the natural outcome of it is that what is going to happen is those who are actually pushing poor practice that completely overshadows the complexity of the problem, are going to be reinforced. And the fire brigades are no different in this case. So effectively, you might have the best possible people and with the best level of competency, and then eventually they will get undermined by a system that actually favors the people that actually say there is no problem, because the statistics say so.
Yes, thank you. And as an aspect of that answer, do you agree that because of the statistical improbability of the need for a full or significant partial evacuation of a high-rise residential building which has a stay-put strategy built in, fire and rescue service policymakers decided not to train firefighters or incident commanders on that eventuality, or only did so in a less than thorough way?
Yeah, this is how things become become institutionalized, in the sense that then the policies start reinforcing this, and then eventually, you go into this cycle, that Judith Hackett described as the spiral down.
So, can we put it this way, that fire and rescue services considered that the presence of a stay-put policy was effective to eliminate risk altogether, both in frequency and in severity terms, in all but a statistically insignificant number of cases?
Yes, and what was missed is the consideration that building fabric was changing, in the process, making that assumption not necessarily correct.
And to put that point a different way, and I apologise for doing it, but it's so that I understand it, apart from anything else, was the flaw in that thinking that at least the severity of the risk could be magnified in unknown and uncertain ways by new building products and methods?
The new building products and methods bring a certain level of complexity,
right,
that adds an enormous amount of uncertainty. Now, that doesn't mean that it is in an unpredictable manner. All that means is that you're making the problem much more complicated to assess.
Yes.
Would it be right to say that the the problem of dealing with the very rare but very serious event involves a degree of judgment? I mean, to call it a cost-benefit analysis is rather demeans it, I think, but it is a question, I imagine, in some cases, of deciding whether the cost of guarding against a very low risk is worth it.
Yes, this is why you consider both probability and consequence.
But you've got to know what the consequence will be, so you can make that judgment. Is that fair?
Exactly. That's the whole thing. You need to know what the potential consequence is, so you can actually make the judgment if the probability, is low enough. This is what earthquake engineers will always do. Yeah. You design for a certain level of earthquake that is the 1 in 100 years or 1 in 200 years, and you don't design for one that is the 1 in 10,000 years, because the cost will be too high. Now, in the case of fire, this is particularly complex because it is our decisions in design that create the event. Yeah. So if a building has no fire safety provisions, every building will perform as bad as Grenfell did. But if we start putting provisions in place, then we are drifting the problem into this design fire that we can manage. And so our mistakes in the design process effectively determine the 1 in 100 event that you could potentially achieve. So that balance is very difficult in fire.
And I don't know, it sounds to me as though the one criticism would be that people didn't sufficiently understand the magnitude of the consequences if the unlikely event were to occur, and therefore couldn't decide whether it was worth the cost of providing for it or not.
I completely accept what you're saying, but the reality is that given the date of this refurbishment and everything that had happened in the past 10 years, I actually think that is a measure of incompetence at all levels.
Because the signals were there.
They were all there.
Thank you.
Which actually answers my last question on that topic. Let's turn to the second topic which I wanted to cover with you, which was what you call societal expectations and presumed competency of the fire service. Can we look, please, at your executive summary of your report at page 2, this report, page 2. Line 29, you say this: there's a strong societal expectation of the Fire and Rescue Services, reinforced by the Fire and Rescue Services Act 2004, that the structure of the London Fire Brigade and the policies that govern the organisation are conducive to the recruitment, education and training of professionals, such that, and you go on to give some examples. If we go to page 3 and look at one or two of those, if we go to line 43 there, you say this: thus, and you've set out 4 above it, but you say, thus there is an expectation that the Fire and Rescue Services can identify potential design and implementation failures that can affect the performance of a building prior to a fire event. And then you go on, furthermore, in the event of a fire that progresses in a manner that is not consistent with expectations, that the London Fire Brigade can alter response procedures in a manner that enables them to fulfil their duties as defined by the Fire and Rescue Services Act 2004. Now, I haven't taken you through the four instances which are above that. I don't think we need to do that, but we can if you like. But would it be right to say that when you refer to the societal expectation, you're referring to the level of competency and skill that members of the public expect that fire and rescue services will have and display?
Yes.
And is that what you mean by the presumption of competency?
Yes. So basically, there is a presumption that the fire brigades will come in and they will perform their job adequately according to the 4 points that I listed above.
Yes, we probably just ought to look at those. If we go back to the bottom of page 2, the first one is through inspections, capability of gathering information, identifying and enforcing rectification issues that would result in a less than satisfactory outcome in the event of a fire in complex modern infrastructure. And if we turn the page to page 3, recognition of how the actions as responders intersect with design philosophies. 3 is operational command structure functions, and the 4th is a further expectation that the commander and subordinates will communicate in a manner that enables a response that will lead to a satisfactory outcome. So those are the assumptions. Would it be right to say that all of those societal expectations are specifically the assumption that the FRS will be able to identify and understand potential design failures are justified?
Yes.
So this isn't a question of society making unrealistic expectations and demands on fire and rescue services?
I don't believe so.
No. Does it follow from that the legislative framework under the Fire and Rescue Service Act 2004 contemplates that fire and rescue services will provide personnel with the degree of competence commensurate with the proper discharge of the obligations under that Act?
I believe so.
And particularly Section 7.
Yes.
Yes. You've set out the text of Section 7 in the report. We don't need to look at it. But if you go on at page 15, if we can turn to page 15 in this report and look, please, at page 15, line 538. you say there, as clearly articulated in my Phase 1 report, there was sufficient evidence from fires worldwide that indicated that certain facade systems represented a significant risk to external fire spread and therefore the safe implementation of a stay-put strategy. Now, is it right that what you're suggesting there, that the societal expectation that fire and rescue services would be prepared for the need to deal with a fire that did that was rational and justified?
Absolutely.
Yes. And that was reflected, as I think you go on to say, in the broad terms of the legislation.
Yes.
Right. Now, you then go on, I think, at 553, if we can lower down the page that's now in front of you on the screen, to say at 553 as follows, in the third line, this perception is also very strong within the fire service itself, where there is a clear sense of ownership of everything related to fires. Is that something that you've observed in your own experience of working with fire and rescue services?
Yes, very strongly.
And would you say that that strong internal presumption of competency is part of the problem?
I will say so.
A lack of awareness, is this right, within the fire and rescue sector itself as to the limits of firefighter competence?
A key aspect of professional practice is to know the limits of your competency, and the awareness of the limits of your competency is a fundamental practice of a professional. And I think that this is an aspect of the fire and rescue services that I do believe is not very well developed.
And when you say your competency, we're not talking necessarily here about individuals, but organizations.
Absolutely, particularly when it's an organization. If I'm exercising as a professional, that is my own responsibility. But if I'm exercising as part of the organization, it's the organization's responsibility to make sure that those who they deploy are only deployed in spaces where they are bounded by their levels of competency.
Yes, and that level and presence of competence, is this right, needs to be present in those parts of the organization where it's needed.
Absolutely, because if you think about it, if I manage an engineering company and I'm sending an engineer that is completely underqualified to perform a job, and the job is done really poorly, then am I going to blame the engineer who did the job for doing a very, very bad job if I am aware that the competency was not sufficient? You know, this is where the organizational responsibility comes in, because the organization, being aware of the necessary level of competency, is bounded to transmit the level of competency down and only deploy professionals within the bounds of their competency.
And to cut through it, in relation at least to the LFB and the Grenfell Tower fire itself, are you referring to the limits specifically in relation to two things? First, the ability of those within the LFB to understand building design and the potential for design failure.
That's one.
And the second, or a second, the ability to alter operational response procedures when faced with a building that fails.
That's two. Can I say a third?
Yes, please do.
You know, they fulfill a role within the fire safety strategy, and they have to be perfectly aware of what that role within the fire safety strategy is.
And if the fire safety strategy contains or demands things that the fire and rescue service have never seen before, what then?
Well, this is where the dynamic risk assessment comes in, and being prepared to take the appropriate actions. It is an element of the competency that you have to provide, you know, particularly to your officers.
Is it just that, or is it that at the information gathering stage before an event, and therefore before the dynamic risk assessment ever needs to be made, that the FRS has the relevant information and competence to interpret it?
No, absolutely. I mean, I think the feedback loop is the first point by which you gather that information. And then, of course, once you are at the scene, then your ultimate approach is to follow an adequate fire risk assessment.
Yes. Now, Mr. Chairman, we're about to turn to a new topic, which will not comfortably be finished by 11:15. We're making excellent progress, but it might be an appropriate moment for a
That would suit you.
break. Yes, it would.
All right. Well, as you know, Professor Torero, we have a break during the morning and the afternoon sessions. We normally have it a bit later than this, but it's better not to interrupt a flow of questions and answers, so we'll take it now. We'll come back at 11:25, please. And as with all the other witnesses, I have to ask you please not to discuss your evidence with anyone while you're out of the room.
No problem.
All right?
Thank
you very much. Would you like to go with the usher, please? Thank you. 11:25. Thank you. Yes, would you ask Professor Torero to come back in, please? Thank you. All right, Professor, ready to carry on?
Yes.
Good. Thank you very much. Yes, Mr. Miller.
Thank you, Mr. Chairman. Professor, I'd like to ask you now some questions about the Fire and Rescue Service's duty to obtain relevant risk information about a building. We've looked already at the concept of the dynamic risk assessment briefly, and that's, I think, the means by which a fire and rescue service implements adequate and effective operational responses in the face of a fire where it doesn't behave as a design fire. Yes?
Yes.
Yes. Now, you've explained, I think, that an effective dynamic risk assessment is underpinned by the information that the Fire and Rescue Service has obtained about the building during its inspections.
Yes.
Now, to be clear, when you refer to inspections, I think you're referring to the requirement imposed on Fire and Rescue Services under Section 72D of the 2004 Act.
That's correct.
Yes. And that process of collecting and maintaining information, is this right, may well be different across different fire and rescue services in the UK.
Yes.
So there may be local variations in the manner and efficiency of collecting and holding such information.
I would say it should be objective driven. So depending on different jurisdictions, you might make different decisions on what information you collect, how you collect it, and how you keep it and distribute it.
You say depending on different jurisdictions. Do you mean local jurisdictions within the UK, or do you mean internationally?
No. I mean within the UK. I would say when I use the term jurisdiction, I just mean an area.
And would those different decisions on what information you keep or you collect and keep vary because of the different types of the built environment or building density?
Absolutely. I mean, it would not be the same type of information that you will collect in the city as you will collect in Hemel Hempstead, for example, or any Highgate. These are different areas with different characteristics, and you will have to take that into consideration.
Nonetheless, is it your opinion that the level of competence, thoroughness, and efficiency, assessing those different risks in different areas of the country, must be to the same high standard?
Yes, it has to be consistent with the complexity of the problem that you're dealing with.
Yes. Now, when we looked at the concept of design fires earlier, we looked at the question of what happens when a building is shown to be compliant, and the assumption that the building will then perform in accordance with that design in the event of a fire. Can we look at page 13 of your report, please, the first report? And if you go to line 479, we can have that blown up. Line 479 says, in what concerns fire safety, the inspection is perceived as the relevant approach to monitoring. The inspection guarantees that all fire safety provisions defined during design remain, and therefore it can be inferred that the expected performance as conceived at the moment of design is maintained. There is therefore an expectation that those conducting the inspection have the necessary knowledge and competencies in respect to building design to enable them to perform such a diagnostic effectively. So, in summary, would it be right to say that, first, the process of monitoring building performance is imperfect because that monitoring can usually only take the form of seeking confirmation that a building is consistent with its design?
That is correct to some extent, but I think this is where competency comes in, because we operate in a system that is based on functional requirements. So there's multiple solutions to every problem. And therefore, the fact that the building is deemed to be compliant doesn't necessarily mean that, on the one hand, has evolved correctly. On the other hand, that current knowledge hasn't superseded what is happening, and also that the solutions that might have been implemented could be very different at each stage. So you really have to be able to understand the system, and then you really have to be able to make an assessment if the building still meets the functionality requirements for which it was designed.
So, yes, I see. So does that tell us that even a building that complies with the functional requirements may still present the risk of a fire that is a departure from a design fire occurring?
Yeah, of course.
You say, of course. It may be obvious to you, but I mean, have I got that right? That
Yeah, you've got it.
Compliance.
Yeah, you've got it right for two reasons.
Okay.
Because the process of compliance is a static process, so you are deemed compliant at some point. Okay, so that doesn't necessarily mean that the building will evolve in a manner such that it remains compliant, and therefore you need to make that assessment. Now, on the other hand, the building was deemed compliant according to an interpretation of a set of ambiguous rules that are set, for the process of compliance at some point, and you might have acquired knowledge through time, past the point where the building was deemed compliant, that now makes you believe that these particular systems require a much more detailed attention. So there's a number of different ways in which that evolution in time can affect your understanding whether the building meets the intention of the building codes. And this is what the inspection is for, to make sure that none of these things escape you and all that information is there. And if you assess that there's a departure from this concept of compliance, you might request a rectification, or you might, if it is not a significant issue, one that can be covered within the operations that you expect to be able to perform in that place, then you will basically just inform the local fire brigades that this is an issue that needs to be considered when introducing operations.
And the process of gathering the information so as to be able to inform yourself as an organisation requires, does it, a level of technical competence and knowledge on the part of those carrying out the inspection?
Yes.
Because it's necessary for those individuals to do two things. First, identify the relevant construction features of the building, and then to understand how those features may fail in the event of a fire.
Exactly, and these are all complex systems.
Yes. Now, you refer in your reports, I think throughout, to inspection. That's the word you use. To be clear, do you accept that the obligation on the Fire and Rescue Service under Section 7.2d is not limited to an inspection, but is wider than that? It's to arrange to obtain information for the purpose of extinguishing fires in its area and protecting life and property in the event of a fire.
I mean, that is exactly the case. If you think of what their obligation is to gather whatever way that information comes in, all the information that is necessary so that they can perform their job appropriately. And if you take the case of Grenfell Tower, if you look at that building and all the fire safety provisions that that building has, the one critical piece of information was the performance of the external cladding. Without that piece of information, there is absolutely no way you can construct a response strategy.
Yes. Now, you say at page 15, if we can just turn back to page 15, please, at lines 533, as follows. You say there is an expectation that through inspections, the fire and rescue services could identify if a specific design could allow a fire to exit the unit of origin. Now, to be clear, when you're referring to this as an expectation, is it also your view that the expectation in fact reflects the extent of the duty, the obligation imposed on fire and rescue services under the 2004 Act?
Yes, because if they don't identify that potential scenario, then they cannot identify the processes that need to be put in place, to release the stay put strategy and then continue the operations.
Yes. And is it that is this right, that if there is a feature of, let it be assumed, a high-rise residential building that presents a risk of compartmentation breach or bypass, then that's information which must be gathered and used for the purposes of the section?
There is, in the fire safety strategy of a conventional residential building, there is no fire safety provision that is a single point failure mode. Everything has multiple redundancies. The only provision that has a single point failure mode is the external cladding.
And yes, I see. Now, in relation to Grenfell Tower, at page 3 of your report, if we go back to that, picking up on a point you made a moment ago, if you go to line 69, you can see that you say there, I'll start at 67 to give it the context. You say, given that the evolution of the Grenfell Tower fire was a foreseeable event, that there was an awareness in the London Fire Brigade of such events, and that the link between these fires and specific types of products was known, a competent inspection would have identified the potential for a large external fire. Is that because the risks posed by certain facade materials were sufficiently well known before the Grenfell Tower fire that LFB ought to have been seeking to identify the presence of those materials on high-rise buildings?
Yes.
And is that because if they'd done that, that would have indicated that there was at least the potential for a large external flame spread in the event of a fire escaping from the compartment of origin?
Not only the potential for a large-scale event happening, but also the potential for this complete cascade of consequences that comes from having a single point failure mode.
A single point failure mode. And a single point failure mode could simply be the dry rising main is blocked, or the firefighting lifts, if they were there, didn't work.
No, because, for example, if you take the case of the dry rise doesn't have any water and the firefighters don't fight the fire at all, you will have 3 layers of compartmentation that will retain the fire within the unit of origin. And the process would have undergone with absolutely no intervention of the fire service, and the building would have picked up the problem. So that's not a single point failure mode, because there are redundancies that will basically stop the event from escalating if one component doesn't work. But if you breach compartmentation from the external facade, that cascades into a number of different things that disable the fire brigades, that disable egress, that disable your doors, that disable everything in the building. So in many ways, this was the critical failure mode of the building.
Yes.
And I would have expected people to be able to identify that.
I was just seeking to understand what you meant, how far single point mode of failure goes. A failure of the firefighting lifts, is this right, would not be a single point mode of failure?
No.
But a failure of building design so that compartmentation no longer held would, because of the adverse consequences that then cascade thereafter.
And there's nothing to stop it.
And there's nothing to stop it. Yes. What that has to prompt the question: what would there be, or should there be, to stop it?
Well, you see, this is where the fire safety strategy comes up. If a proper fire safety strategy would have been done for that building, people would have identified that there was a single point failure mode, and they would have basically corrected, because in matters of safety, you always have to have redundancies. Now, in this particular case, the redundancy was always perceived as being the fire brigade, but without recognizing that the single point failure mode disabled the fire brigade too.
Yes. Now, you go on to say that, or suggest that the inspector, this is at line 71, you go on to say there that the inspector, which is, I think, in other words, the Fire and Rescue Service, obtaining information under Section 72D, should obtain test results and desktop studies. That's what the suggestion you make in line 72 there. Are you suggesting that the LFB, for the purposes of Grenfell and its refurbishment, should have obtained the actual test results for Reynobond 55PE cassette panels and RS 5000, Celotex RS 5000, and Kingspan K15?
The operations of the fire service and whatever strategy they put in place depends on vertical compartmentation. So if it depends on vertical compartmentation, wouldn't you want to know everything that you need to know to guarantee that the vertical compartmentation is retained?
And some might say that that was a counsel of perfection. Is it realistic to suggest that the LFB should obtain, not just know what's going on in the building, but should actually obtain the actual test results for the cassette rain screen and for the insulation panels?
Well, you can take the opposite approach and you can say that they really don't have to have that information, but then they would have had to include within their protocols and practices the potential for that event to happen. And they would have had to put all the mitigating elements to make sure that they could respond appropriately to that event.
And have you ever come across a situation where a fire and rescue service in the UK has asked for, or been, let alone been given, the test results or desktop studies for these products, or these kinds of products?
Yes.
You have?
Yeah.
By the manufacturers?
Yeah.
Really? Can you give us an example?
Well, I mean, they will mostly be now post-Grenfell, no?
Right, before Grenfell?
No, before Grenfell, I was not in the UK, so I didn't have a regular practice on engineering projects, so I didn't really had the opportunity to witness that.
I follow.
Can I just ask, I mean, imagine the first step would be to find out more about the construction of the cladding.
Of course.
And if that had led, as it perhaps it might have done, to an understanding that the insulation was BIR, BUR, whatever, but was essentially combustible in nature, the inquiry might have stopped there without the test results. Is that possible?
Well, it is possible, but I think, you see, when you understand the problem that you're facing, you look at these variables, and then you look at what redundancies you have, and then on the basis of that, you make a decision whether that is an acceptable risk to take or not. And on the basis of that, you create protocols and processes that enable you to actually perform your duties. That's the way I see it. Now, as I say, there is no single answer to the question because you can take many routes to achieve the same objective, but it has to be objective driven. At the end, the fire and rescue services have a job to do, and that job depends on information. And that is what enables them to do the job. And I would expect them to find the information that they need to make sure that their job is enabled.
Yes, I mean, the reason I ask the question is that you say, without qualification, it's incumbent on the inspector to seek this knowledge, example, test results and desktop studies. And I wondered whether it was really realistic to make that suggestion, at least in the time before the Grenfell Tower fire.
I mean, I think it is perfectly realistic because, you know, it's at the core of your capacity to deliver your job.
So when you say it's incumbent, you're not making a statement about what the obligations were necessarily, but what they ought to be.
It's more what they ought to be. Keep in mind that we operate in a system that is driven by functionality requirements where there's no black and white. So this is objective driven. And the fire and rescue services are part of the fire safety strategy, and as such, they're part of this objective driven model in which we operate. And therefore, I would expect them to gather the information that they need to be able to do their part of the job within the fire safety strategy.
And is this right? Separating day from night, if one can. Would that mean that the manufacturers and those in the supply chain need also to do their job and provide with full candour the test results and desktop studies to either the building owner for onward transmission to the fire and rescue service or directly to the fire and rescue service?
Absolutely. The safety is an aspect that has to be, first transparent, and everybody needs to do their part because it is like a chain. And if you have one weak link, that's where it's going to break. So every single component should have done the job appropriately.
Now, we know that the crews who've carried out the visits to Grenfell Tower before June 2017 did not identify the presence of cladding on the building, nor its significance. And indeed, we know already from the evidence before this inquiry that the London Fire Brigade's policy number 633 on high-rise firefighting did not even include cladding in the list of things that a crew should be directed to have regard when visiting high-rise buildings. Are you able to tell us whether, with appropriate training and education, it's likely to be within the competence of station-based operational crews to identify that information?
I think so. I mean, because you see, when you are operating within an organization that has all the adequate levels of competency, the person who is deployed to do the inspection basically gets a series of simple instructions that enable them to do what they have to do. So if these individuals would have been told to identify the product number and its characteristics, that's all the information they needed to provide to somebody that was higher up in the chain to deliver the appropriate analysis.
So does it follow from that that your view is that the responsibility for collecting the information can be relatively instruction-driven, but then it needs to be sent higher up in the organisation for interpretation and decision-making?
Exactly.
With the appropriate level of expertise at each level.
Exactly. So you don't have to always deploy the very, very high level of expertise, at the delivery point. You can have that expertise behind the scenes, but the role of the people that are behind the scenes is to make sure that those who are going to the field that don't have the detailed level of competency, that they know exactly what to look for.
And presumably vice versa, those higher up the organisation who will be looking at and interpreting the information would be in the best position to provide clear instructions to those collecting it as to what they needed to be looking at. And
exactly.
Now, in your second phase 2 statement, if we can go to that at JTO 705, at page 22, you refer to the provision of operational risk information systems guidance, or PORIS. And I think we've heard Mr. McGurk give evidence this week on that. If you go to line 735 on that page, 735, 734 and then 735, you say, so by defining risk information in these terms, having referred to PORIS, both the HMFSI expectations manual and the PORIS document presume an exceptionally high level of technical competency of the fire service. I'm just pausing there. This PORIS guidance was published by the Department of Communities and Local Government in conjunction with the Chief Fire and Rescue Advisor in 2012, I think, wasn't it?
Yes.
Yes. Now, in your view, is that likely to reflect the fact that there was a strong public presumption of competency on the part of the fire and rescue services, which we've already considered, which was shared by government departments?
Yes.
In other words, everybody behind PORIS was working on a particular assumption of a particular level of competency.
Yes.
And in contrast to the complexity and the assumed competence of the user of the PORIS guidance document, we heard evidence at phase 1 from watch manager Dean Ricketts. You'll remember, I think, this evidence.
Yep.
He was a watch manager from the North Kensington fire station. He had conducted a 72D visit, or series of visits, to Grenfell Tower before the fire, and told us that he'd never received any training on how to go about that task. Could you explain, and it may seem obvious, but can you explain what the dangers of not giving any consistent training to station-based operational personnel about how to carry out such visits are?
Well, I mean, the first and foremost is that you will never gather the information that you need. And the second one is, and this is unfortunately the problem with this complex systems like PORIS, is that the terminology that is being used can be treated in a very subjective way, so it can be extremely misleading. So if I make a statement that talks about the characteristics of the fires that can be fought, if you think about the complexity of that statement, it implies an enormous understanding of building behavior. It implies an enormous understanding of equipment. It implies an enormous understanding of the personnel and the competencies of the personnel that you are deploying. All these things are sunk into a term. And that term then, if I am not competent enough to gather the information that I need, I might just simply conclude and say, yes, it can be fought.
Can you give us an example of such a term?
What do you mean by an example?
Well, you say in your last answer that it's a question of language often, and terminology can be used in a very subjective way so that it can be extremely misleading.
Yep.
Can you give us an example of where you see that?
Yeah, so I was trying to give the example of that statement. So, if I ask an individual in the London Fire Brigade, what is a fire that can be fought? Okay? The answer might just simply be, oh, well, this big.
Right.
Okay? Now, I might actually say the same thing. Okay? This big. Okay? But behind the answer that I'm giving, I'm making an analysis of what is the material that is burning. I'm making an analysis of what is the configuration of the fire. I'm trying to understand what else is in the building, how it can ignite other things. Okay? And I can give you exactly the same answer. Now, on the other hand, if I don't have the competency, okay, I might look at the fire, think of a fire extinguisher, and say, well, maybe I can deal with that. And we will both give you exactly the same answer.
Right.
Okay. Now, the problem with these complex systems is that they use terminology like that. So they use terminology that hide an enormous amount of complexity. And therefore, you can give a very superficial answer with the wrong information that be completely misleading and give you a false sense of safety. Well, in reality, what has happened is that they have not introduced all the complexity that is necessary, and they should have come up with a completely different answer.
In your opinion, focusing particularly on Grenfell Tower as a paradigm, is it your view that the national guidance framework that was porous assumed a high level of technical competency?
Yes.
And that high level of competency was not in fact present generally in fire and rescue services?
Yes.
Now, if we go to line 745, about halfway down your screen, just below, you say this. Of particular importance is the absence of any methodology that allows to establish what are the fires that can be controlled or suppressed with the equipment and personnel available to the LFB, and when rescue should be prioritised over fire suppression actions. And finally, none of this guidance provides any information as to the technical competency required from the user of these systems. Thus, the presumed technical competency of the incident commander remains undefined. Would it be right to say that those responsible for collecting operational risk information in respect of modern buildings and refurbishments need to have a far deeper understanding of fire safety engineering principles and up-to-date construction methods and practices in order to do their job?
I believe so.
Yes. Now, I want to turn next, please, to the dynamic risk assessment, which we touched on earlier, but I want to look at it now a little bit more closely with you. If you go to page 16 of your first report, please, your first report, JTO R702, page 16. And if you look at line 575, you say this: any variation from the norm then becomes a matter for a dynamic risk assessment plan formulation, defined by those preparing to interact with the fire. For a dynamic risk assessment to be effective, the fire event must be understood by those conducting the assessment. Thus, a dynamic risk assessment is only expected to extend firefighting protocols to variants that are reasonably close to a more typical fire event, the design fire. Now, to be clear, the reference to variation from the norm, is that a reference to an unexpected fire or building behaviour?
Yes.
So, in other words, a non-design fire?
Yes.
Yes. And are you able to explain exactly what you mean there by plan formulation?
Yes. So again, I'm very careful with the way I use the language. I think one of the biggest problems that we have in the space of fire safety is that a lot of the research that we use to discuss these matters is borrowed from other disciplines, and therefore the language that we import sometimes is used by people in completely different ways. So I defined plan formulation, as opposed to plan execution, as two distinct processes. Plan formulation is when you define the problem. So you take all the information that you have, you define what your problem is. The plan execution is the resolution of the problem. Now, normally, when the problem is very well known and it is predefined, so the design fire, so you've already predefined that problem, you can move straight into plan execution because you define policies and practices that have already been defined to solve that problem. So you create a set of instructions, a recipe, and then people can actually utilize that recipe to develop the solution. That's a direct plan execution process. Now, when you have plan formulation is when you are required to do the dynamic risk assessment because your original set of premises are no longer valid, and you have to make a decision of how you're going to change an approach to the solution, how you're going to execute the solution. So you're going to formulate the problem first, assess your different approaches, and this is where the different forms of command, for example, happen, that you can have different ways that Dr. Cohen-Hatton was talking about, different ways in which you can approach this, and eventually leads you to a position where you're confident that you can actually execute a plan. Okay? So in this case, when I'm talking about plan formulation, is what are the variables that you need to be able to define an appropriate plan of action in the event of a situation like what happened at Grenfell. And maybe if you indulge me with an example, maybe I can illustrate that, what exactly do I mean. So the moment so you have a fire that is in a kitchen, and you have your plan execution process of going and fighting that fire in the unit. Okay? At some point you realize that that is not working, and you see a fire on the outside. Okay? This is a moment where you have to get all your information. The first piece of information is what is the consequence of losing compartmentalization. If you don't understand what the consequences of losing compartmentalization are, you will not be able to define an appropriate or formulate an appropriate plan. So that's one piece of information. Then you need to start by what you are observing, the information that is coming to you from the rest of the people working with you, and by your own competence and knowledge, you have to define how this event is evolving so that then you can direct your decisions. Now, I can be extremely simplistic in the approach and say, okay, the moment a fire exits a window, if I just simply take pure statistics of the events that had happened in the past, I will tell you that it would probably be between something of the order of 1 meter per minute, to 15 meters per minute at the most. Okay? So basically the speed of the fire would have been of the order of that. All I had to do was take past statistics and just basically say, well, this more or less bounds it. I know I have a fire that is going to be progressing at this speed. Then now I can make a decision of what to do next. Now, if I have more sophisticated knowledge, I can actually refine that because I can say, oh, well, these fires grow at a certain rate. And the laws of physics defines a function of time that determines the fire growth. And I might be able to refine it and say, well, actually, I don't have 20 minutes, but actually I have about 40 minutes. Okay? Or I can actually use information. In other words, I can look at the flames and I can start monitoring the variable that I think matters, which is how fast the fire spreads. All I need to do is take my watch and look at how the flame is growing, and I can assess what the velocity is going to be. And that will give me the time that the fire will get to the top. And I will do it just purely on observation. But on the basis of that information, which is my knowledge, the observations, the information that I have, the understanding of the fire safety strategy in the building, I can construct an approach towards the intervention. That's what plan formulation is.
I see. Can I just, there are a couple of things in that answer which I just want to go back on. The first, you say the first question is compartmentation going to hold? Or words to that effect. I was wondering whether, in fact, the first question that an incident commander seeing that there was a flame outside the window and that the kitchen fire had not been contained is, or might be, what is on fire out there and why is it on fire? Would that be fair?
Well, that would be fair. Now, keep in mind that a flame outside the window is an acceptable proposition. It is when the flame progresses beyond the unit of origin and starts entering or sort of moving into the space of the next unit when you have theoretically breached compartmentation. So it is not an unusual event for flames to be outside the window. Now, the moment that you start seeing polyethylene dripping in flames, okay, and the flames creeping into the cladding, which is a few minutes into the event, at that point you recognize that there is no barrier to stop that. And at that point, you have to start thinking. Now, I might be too demanding of the commander that was at the time. And of course, I am being too demanding of the commander that was at the time. Okay, I'm not expecting maybe those nuances to be able to define at that point. But then 3 minutes later, now you have a flame that is impinging on the window above. Now you know you have breached compartmentation. Because once the flame is impinging on the window above, then at that point you know that your fire safety strategy has fallen down. And then you have to start taking all these measures. Now, obviously, my position is that that information, that knowledge, that understanding of how to formulate a plan is something that commanders would have come in, with that training and competency.
Second thing that follows from that longer answer, but also what you've just said, is would it also mean that the incident commander responding wouldn't simply look visually at what the fire was doing, but would also be alert to other sources of information? For example, whether people were self-evacuating, at what rate, from which floors, were any survival guidance calls being made, how many fire survival guidance calls were being made, from which floors?
Absolutely. So you formulate a plan on the basis of all the information that you have available, and in some cases it's going to be less, in some cases it's going to be more, but the more you have, most likely the better your plan is going to be.
And would it be accurate to define plan formulation, coming back to the expression, as the identification and prioritization of objectives at the incident based on information from as wide a variety of sources as you can?
That's exactly what it is, and is what enables you to then formulate a plan.
Yes. And you've distinguished plan formulation from plan execution. Plan execution, is this right, is just executing the plan you formulated?
Exactly. So in the case that you go through plan formulation, then you execute the plan. But in the case that everything performs according to the design fire, then the plan would have been already formulated by guidance, by policy, because that's what we expect.
Yes, and on that, having done your plan formulation and go to the execution stage, would you expect a competent, with levels of competency that you're proposing, a competent incident commander, having done the assessment and formed the plan, then to execute it in accordance with the plan, not necessarily in accordance with a predefined procedure or protocol?
Well, there is no, if the moment that you do a dynamic risk assessment, there is no predefined, you might use components of procedure and protocol. So you're not going to change the way in which a firefighter should be holding the hose. Okay, so there's elements of procedure that will remain in your plan, but there is no longer a procedure or a protocol that is predefined, even if all you're changing is a tiny, small element of the entire thing.
Yes. And would I be right to detect in your answer the concept that the more you reduce operations to policy, to protocols, if you like, the less space there is for plan formulation which does not accord with those policies.
Well, I mean, this is I think one of the biggest problems that we have, and again, it always brings us to a misunderstanding of language. The moment that you define everything that you do in terms of policy, it can only mean two things. One is that you know everything, so you can turn everything into policy. So you have literally defined all the potential options. There is nothing else that can happen, and therefore, I can have a protocol or a policy for everything. That's a purely prescriptive environment. Okay. Now, the moment that there is an element of uncertainty or is an element of lack of knowledge, then you have to depart from that. Now, if it's very, very, very small, then you probably have to depart in a very forceful way, because obviously you have a culture that is functioning in terms of prescription. So you have to be very forceful and making sure that there will be individuals within the organization that can understand this and transmit the value of it. Now, when you start making the environment more lax, and then you get more and more and more options that could potentially happen, then this becomes the routine. And you operate in spaces where you're fundamentally always operating in plan formulation. This will be the operating table for a brain surgeon. There's very little procedure for the brain surgeon. Most of it is going to be its own plan formulation.
Yes, I see. Now, going back to the report at line 577, which is about a third of the way down your screen, you say, thus, a dynamic risk assessment is only expected to extend firefighting protocols to variants that are reasonably close to a more typical fire event, the design fire. Can I ask you this? If the dynamic risk assessment is being used where there is any variation from the norm, what makes it only expected to extend to variants that are closer to the norm?
Well, and this is one of the complications or the variables that needs to be addressed, because clearly you have staff and equipment that have a capacity. And when you have staff and equipment that have a capacity, you cannot have a variant that exceeds the capacity of what you're bringing in. Now, obviously, we have the capacity to escalate that, but we have seen, all the problems that get generated, congestion, the radio problems, all these different things that start happening when the event escalates to a situation in which it has deflected itself way far from the design condition. Now, the way you prevent that is through the inspection and by identifying these things ahead of time. So you have to make sure that those variants or the range of variants that you're operating with has to be a range of variants that is consistent with the skills, equipment, and a number of personnel that you're deploying to the event.
I'm just wondering whether there's a contradiction in terms here in this line in your report, because you say that a dynamic risk assessment is only expected to extend firefighting protocols to variants that are reasonably close to a more typical fire event, and yet you use it when the design fire has been departed from. So how does this work? Do you use a dynamic risk assessment when you haven't got a design fire, you've got a non-design fire? And if that's the case, why are you bounding it to a fire that is reasonably close to a design fire?
Because you're bounded by your hardware, and you're bounded by the number of people that you have available. So in many ways, I have a design fire, and I can respond to those design fires appropriately. Okay, but I can have variants to that, and I need to conduct a dynamic risk assessment. But I only have this many tools. So if I run out of tools, then I cannot address the problem, even if I'm doing the perfect competent decision. If the conclusion is I need 400 men now, you will never be able to address the problem. So it's always bounded, by the constraints that are imposed by the physical means that the commander has to deploy.
I see. So when you say a dynamic risk assessment is only expected to extend firefighting protocols, etc., I think you mean that in reality, an incident commander can only conduct an effective dynamic risk assessment within the limitations of what they have.
Exactly.
Now, there are two further questions on dynamic risk assessment I think you identify in your first Phase 2 report, this report. First, can we look at 581, the following paragraph? You say this: firefighters that directly interact with the fire will have the greatest capacity to acquire information, and therefore the natural tendency is for those individuals to conduct the dynamic risk assessment and consequently make all subsequent decisions. Fires evolve rapidly in time, so time is at a premium, and firefighters will generally privilege a rapid decision to the transfer of information to a command unit. And at 589, you say, conducting a dynamic risk assessment is therefore not necessarily the prerogative of the officer in command, but there is a presumption that all responders are equally responsible and qualified to deliver these assessments. Now, I've shown you those two passages. Now, first, to be clear, you say all responders, and is that because the LFB's Dynamic Risk Assessment Policy 342 says, it's at paragraph 1.10, that all, written in bold type, personnel in the operating and training environment must undertake a dynamic risk assessment continuously?
Yeah, I mean, I think this is something that we always have to keep in mind. Fire is a very unique type of event because it evolves in space and time in a very rapid manner. So there is a convergence of the event with different types of individuals at different types of situations. Now, obviously, the decision-making, the dynamic risk assessment that a commander will make, that implies the deployment of resources and the overall assessment of the situation will be completely different, to the individual who arrives, sees a room on fire, and finds a child under the bed, in which case they will have to change the path and make a decision. So they will be conducting a dynamic risk assessment. It will have a lot less variables, it will be much more localized, and it might actually be much simpler in nature. So that will be the competency that the firefighter that is at the tip, of the whole structure will have to exercise, which is very, very different to the competency that a dynamic risk assessment conducted by a commander, will have to be exercised that involves numerous other variables.
Yes. Does that mean that there is a risk that if everybody's doing their own dynamic risk assessment, there's scope for confusion and inconsistency in the decision making?
Well, I mean, that is one of the fundamental risks in firefighting command. And I think this is one of the biggest weaknesses that we have in our understanding of firefighting command. Many times, as I say, we try to import and the different approaches that are followed in different sectors like the police or the military and try to adapt those concepts into firefighting. Now, unfortunately, we have never ever given the attention to firefighting command, the sufficient attention to firefighting command to understand how you resolve those conflicts, because the conflicts are natural. It is the fact that you have an individual in front of the event having to make decisions where they have to make priorities, and those priorities might result in informing the commander after executing the task, just because the event is evolving in space and time. Okay? Now, the problem is that if we don't really truly understand how command for firefighting works and how you resolve those conflicts, we will never be able to actually create a proper command structure.
And how would you address that problem?
To be honest with you, I have absolutely no idea. This is an area of research that has been ignored for decades. And it's an area of research that has been left completely untouched. And I have to say that the work of Dr. Cohen-Hatton is probably, a light, in this darkness. There's very, very few people that have actually put the effort to understand what is necessary to be able to solve all these conflicts that are absolutely the nature of the problem. So this is nothing that we're going to resolve from one day to the other one. This is something that really needs long-term and serious attention, involving, sociologists, psychologists, individuals who understand concepts of command, as well as engineers who understand fire.
Yes. We'll come to Dr. Cohen-Hatton's papers a little bit later, perhaps. But Is the fact that a dynamic risk assessment is not necessarily the prerogative of the officer in command, as you say, a sign of a weak command structure?
Improperly managed, of course, that's what ends up happening. That if you're not managing it appropriately, the natural tendency is to a weak command structure. And this is why, in many ways, the fire service is a single entry, flat environment, because everybody is perceived as being the same. And the way in which you acquire the experiences and the way in which you progress among the ranks is in many ways undifferentiated, when it comes to your competency, skills, and attributes.
Well, I noticed you say in line 586, you refer to the hierarchies existing. I think in effect you're saying more in theory than in practice.
Absolutely.
And is that a weakness that you would identify?
Yeah, it's a resulting weakness of us not really truly understanding how to establish a proper command structure within the fire service.
Yes, thank you.
Now, the question of a variation in quality and effectiveness of decisions made by different operating personnel is a matter that Mr. McGurk considered in his Phase 2 report. And I'll give you a little bit of a run-up to the question, but he referred to two examples of activities carried out on the night of the Grenfell Tower fire by a BA crew manager Tillotson's crew, and also by an individual firefighter O'Byrne, who both made the decision to take action that they had not been explicitly instructed to carry out. Now, Mr. McGurk's view was that they were slightly different. The action taken by the crew manager Tillotson, even though outside procedure, was an example he thought of effective and legitimate exercise of initiative involving a proportionate degree of risk that resulted in the successful rescue of some residents. That was his view. Would you agree with that?
I mean, the outcome was successful, yes.
But in structural terms, would you agree that it should be applauded and retained?
Well, the question that I will ask is what was the logic that was followed, and I will do an analysis of what are the potential consequences of that action and learn from the outcome. I mean, obviously, there's an element of intuition, there's an element of experience, all these things are going to play. But for every positive outcome, there's potentially a negative one when you depart completely from protocol without having a proper logical justification. So for me, it will be more about why he did it and how he reached to that conclusion.
Right. And in the Tillotson Crew's case, it was in the exercise of initiative, as it was, I think, called, by going down and collecting 2 BA sets and taking them back up to the 9th floor to allow the residents on that floor to use them and effect a successful evacuation.
So the outcome was the same?
Yes.
Yeah, so the outcome was the same, but how can we come up to the conclusion that one was an inappropriate use of dynamic risk assessment and the other one was an appropriate use of dynamic risk assessment? The way Mr. McGurk arrives to this decision is by making an analysis of the pros and cons, and he is doing the analysis a posteriori, and he's coming up to that conclusion. I think that is a perfectly valid approach to analyzing that type of information, which, to me, all that means is that this is part of the process of understanding how these decisions are made. But it is not really a way in which you can put judgment on whether one decision was good or it was not, because they both attain the same objective. I don't know if I'm being clear with that.
Well, let's see if we can illustrate. Let's see if I can help illustrate your opinion by reference to that example. If the outcome had been that the residents were rescued, but taking 2 BA sets from a pile in the lobby had meant that 2 incoming firefighters did not have a BA set available, which would have affected firefighting operations, that would have been an adverse outcome.
Well, once you balance it, yes. If those 2 BA sets then were needed for something else, probably, for example, disable the rescue of other 8 people, you would have made that assessment a
Yes.
posteriori. But this is the kind of assessment that you would expect the individual, who is taking the action, would have waited before taking such an action.
Yeah, that's my next question. So the use of the dynamic risk assessment by that crew would have involved weighing the pros and cons, first of all, of leaving the residents where they were and going down and collecting the sets and coming back, and secondly, taking the sets themselves.
Yes, and I think one of the things that many times tends to confuse things that I think is very important to clarify is that when we are making this a posteriori assessments, we're talking about a period in the fire where effectively the whole system had broken down. And the fire service was no longer capable of operating in a structured and rational manner. So they were basically overwhelmed by the event. From my perspective, I think focusing too much in that period is completely missing the point. Because the reality is that the full objective of the intervention is to never get there. And where all the proper dynamic risk assessment and the proper decisions should have been made is at the point where we did not have to escalate the event to that level of confusion and that level of chaos, where then, of course, making an a posteriori analysis, looking at what happened, is perfectly logical and perfectly fine as a learning exercise, but not as a judgment of whether this was an appropriate approach or not.
I see. So is what you're saying that you look at the outcomes and you can learn from the outcomes, but it doesn't tell you necessarily about the quality of the decision making that led to it.
Exactly, because you are at a point where decision making is not only what prevails. You're basically scrambling, trying to fix a problem that has already overwhelmed you.
Taking the second of his examples of the use of initiative, this was firefighter O'Byrne. His view was that, and I should just say, he ascended the tower and got as far as about, we think, the 12th floor at an early stage, very early stage, before the fire in the cladding had really got hold. And his action was regarded by Mr. McGurk as well-intentioned but not reasonable or an effective course of action, not least because it carried the risk of a lost firefighter and therefore the diversion of firefighting resources, because no one knew where he was. And had no radio comms. Now that's an example at a time before the fire got out of control. Would you agree with Mr. McGurk there that was not a good not a useful or sensible use of initiative?
Yeah, I would agree. And it is at a stage where you actually can make that judgment.
And are you able to offer a view based on your experience of working with fire and rescue services as to why it is that this type of unilateral action occurs amongst operational personnel?
It is something that tends to happen because it is the individual who is in front of the fire who is the closest to the event. So you're constantly being psychologically reinforced that you have the right information to make the decision on the spot. So it is nothing that we don't know. This has been known for a long time, that when you're very, very close to the event, cognitively speaking, very rapidly you believe that you are the one who has the most information to make the decision. So this is why a lot of procedures are put in place to try to pull people away from feeling in that way. So it is a natural thing to happen, and but when it contravenes procedures and it creates situations that are known to be negative, this is when you realize that either the training that you provide this individual was inappropriate, so it was ineffective, and or this individual was actually not conducting himself in an appropriate manner.
Yes, I see. Now, that was the first issue, divided into two. But the second issue that you identify in relation to dynamic risk assessment is one that you set out at 576 on this page. And you say at line 576, you say, the fire event must be understood by those conducting the assessment. When you say that the fire event must be understood, what do you mean there?
What was very, very much the example that I gave. The moment that I see the flames coming out of the window, there is an element of understanding of the event that I have that enables me to get a sense of what the progression of that event is going to be. Now, keep in mind that one of the key aspects about current approaches towards firefighting is, given the delays in arrival and from the moment of detection, alarm and calling the fire brigade until the moment of arrival, most of the fires in compartments that firefighters are fighting are fires that are already fully developed and they're contained by walls. So you're going to have a fire that already has reached its maximum stage, and it is contained by walls. Now, firefighters are very familiar and very confident with that type of event, and is one that is embedded in the mindset of firefighting. Now, when you have other types of fires, like are spreading, and therefore they're growing at, in an unrestrained manner, then you need a much higher level of competency to be able to make that level of assessment.
Mm-hmm. And does it follow from that the person conducting that assessment not only needs to understand what the fire is doing, but why it's doing it, how the building is responding, and how the building will continue to respond, and the fire will likely develop?
Absolutely. And as I say, they are, many times people think, and I've expressed it in my second report, that if I want to precisely model the speed at which the fire grows, is an incredibly complicated process. But I can start using simpler models, and I did that in my phase 1 report, that I insisted that given the information that we had, we wanted a much coarser and simpler model. And or we can go to just simply estimates. At each stage, we'll go conservative, but different, within the hierarchy of command, different levels of commander, will be able to be more refined. But even the first incident commander should have some level of understanding that enables them to make these early decisions on the basis of an understanding of what are the potential consequences of what they're actually seeing.
I'm interested in what you mean there by some level of understanding. Is it right that in order to do a proper dynamic risk assessment, as you identify here, the person doing it needs to have the same amount and quality of information that should be gleaned from an adequate 7.2D information gathering exercise about that building?
I mean, that will be key. That will make their life much, much, much easier if they had all that information, and that information had already been assimilated. So they would not have to do the entire processing, in place. All that would have been done ahead of time. And so if you knew that you have this type of materials and you decided to accept them, then you would have processed what kind of intervention you will have in the event of a fire, because you would have understood what was the potential failure mode of that particular building. Now, if you don't have that information, that doesn't completely disable you from making a dynamic risk assessment. You still can respond. You are handicapped by not having all the information, but nevertheless, if I was to go to a classroom and teach a commander that was going to come in and said, if you see a fire that compromises any adjacent unit, you have to understand that your whole fire safety strategy has collapsed and that your fire will grow between 5 and 15 meters per second.
Yes.
That information is information that will become universal for this type of buildings. That's all that they need to have to be able to understand that that fire is not going to stop. Now, Mr. McGurk showed, for example, the effect of water in trying to control the spread. So they will understand also that if they throw water at the fire externally very rapidly, that might slow things down and gain them a bit of time. But in principle, they should be working on the premise that they understand the range of velocities that spread of the fire will have and what are the potential consequences for all the people that are there. And given then the resources, they will deploy them in the most effective way to try to get the best possible outcome. Or call for more resources, but they can start making decisions. They formulated a plan and they can start executing that plan.
So I think you say that, is this right, that to do a proper risk dynamic risk assessment, an incident commander or the person properly making it should have the same amount and quality of information that would be gleaned from a statutory information gathering exercise. But if they don't have that, then the fallback would at least be to know that where you have an external fire, you're going to have, or may well have, uncontrolled and rapid fire growth.
Yeah, so basically it would not be ideal not having the information, but that doesn't mean that you cannot formulate a plan.
And am I right in thinking that the formulation of that plan, based on at least the minimum amount of information to do it, is not something that can be left to all responders, but only to the incident commander, properly trained and with all relevant information?
Exactly.
Yes. Now, about the level of confidence, you say at line 594, at the foot of your screen, now in the middle of your screen, the level of competency required to successfully conduct a dynamic risk assessment is directly linked to the extent that a building's characteristics have to enable a fire to depart from the standard characteristics, i.e. the design fire. The more complex the building, the more the potential for a significant departure, and the more difficult it therefore becomes to identify the course that will be followed by the fire. Consequently, the competency required from those performing a dynamic risk assessment is intimately linked to building complexity. Furthermore, research has shown that the situational awareness necessary for an effective dynamic risk assessment is intimately related to the nature of the training and education of the responder. Now, looking at the first sentence there, the first sentence, which starts, the level of competency required to successfully conduct a dynamic risk assessment, is linked to the extent that a building's characteristics have to enable a fire to depart from the standard characteristics, i.e. the design fire. I'm afraid I had a bit of trouble understanding that. Could you just explain what you mean there?
Yeah, so depending on the building complexity, there is a greater potential for unforeseen progression of the fire. So if you have a very, very simple building, then it is actually very simple to predict with a lot of precision what is going to happen. Well, when you have a very complicated building with complex components and so forth, then the complexity of the system makes it more and more and more difficult to come up with a proper assessment of all the possibilities that can happen. This is why we have redundancies and so forth. So when I say that the level of competency required to successfully conduct a dynamic risk assessment is directly linked to the extent that a building characteristics have to enable a fire to depart from the standard condition, what I mean is that if I have a really complicated building that has the potential to depart, quite widely, that will require an individual with a much higher level of competency to be able to do a proper dynamic risk assessment.
Is it always the case that the more complex the building, the greater the likelihood that a fire will depart from the design fire?
Well, you see, this is it shouldn't be. At the end, we should guarantee that all buildings should have the same level of safety. When you introduce complexity, it is incumbent to the designer to introduce robustness. And so if the complexity is very high and you have multiple possibilities that you actually don't have the tools to predict appropriately, in principle, you should be putting in place other elements of robustness that help you compensate for that.
So you could have a very complex building, but one which has superbly well fire-engineered prevention and protection systems designed into it, where the fire which does happen is very likely to be a design fire.
Yes.
Is there an inevitable connection then between building complexity and the probability of a design fire?
Yeah, absolutely.
And why is that?
Well, because,
Sorry, can I put the question again?
Yeah.
An inevitable connection between building complexity and the probability of a non-design fire?
Yeah, I would interpret both the same way, but
right.
But yeah, no, basically, if you enhance the complexity, okay, you are going to enhance the probability of a non-design fire. But it is incumbent to the designer to bring the probability back to a place where it's appropriate. Okay, that's one element. So you can actually operate by putting robustness to bring the probability back okay? Or you can operate by putting robustness by bringing the consequences down. So you can do the two things.
Now that depends, doesn't it, on whether your building designer understands the concept of complexity. As a starting point, could you give us some idea of what constitutes a complex building?
It's very interesting. I mean, that's a very important question, because many times people think that a very tall high-rise building, is a complex building, and they are complex buildings. But sometimes very, very small buildings are incredibly complex. It is the way in which you construct the building, what are the components that you put in place, but particularly how well you understand those components. So, for example, I can design, two buildings, 4-story buildings that are identical. Okay, one is designed using timber as a structural material, and the other one is designed using steel as a structural material. The complexity of the timber building is much, 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 much higher than the complexity of the steel building when it comes to fire. Nevertheless, I can design both buildings to equal level of safety, to probability and consequence. But the designer of the steel building could probably be a conventional graduate, but the designer of a timber building will have to be a top-notch engineer. So it's the competency of the people performing the design that brings you to what society wants, which is an equal level of safety.
Yes. Do you detect an absence of competence in those designing buildings in the United Kingdom to understand that what they are designing, whether it's from scratch or by way of refurbishment, is complex?
Well, this is one of the biggest problems that we have, and I think when I started my first report, I made sure that when I put the list, I went from manufacturers to fire brigades, because I think everybody has the same responsibility, and it is very clear that when it comes to the design, of buildings, we suffer from fundamentally the same problems. So we have these building regulations that have no problem formulation because they don't require a fire safety strategy. So we're still operating under basically plan execution. And so everybody, the whole mindset of fire safety in general is driven in a very, very similar way. So the same deficiencies of competency that you might be identifying in this module in regards to the fire brigades apply across the board, to every single aspect of the whole discipline, because we have never been able to move away from execution on the basis of very prescriptive set of rules into a place where we actually need to formulate a plan that enables us to attain the objective.
Would it be oversimplifying it, though, to say that on the whole modern residential high-rise buildings are complex constructions that potentially present significant risk of unexpected fire behaviour?
The modern residential buildings right now are extremely complex.
And as a result, do they present significant potential for unexpected fire behaviour?
Yes, because the complexity stems from our misunderstanding or lack of understanding of the performance of the components. We've created components that we do not know how to implement correctly. We have no idea how to assess their performance, and we don't know how to maintain them. So we've embedded all this complexity into the system, and as a function of a complete misunderstanding of performance when it comes to fire.
Focusing more on the level of competency actually required for those carrying out dynamic risk assessments at an incident involving a modern high-rise residential building, is that level of competence essentially the same level of competence as required of those responsible for collecting the risk information about a building before the fire happens?
I will go. The answer is yes, but with the caveat that it's not the ones who collect, but it's the ones who request the information and the ones who will be analyzing the information. The person that collects in the same manner as the firefighter who is actually the direct responder might have a different level of competency so long they are directed by somebody who has the competency.
Yes, I see. Yes, you said that before. And when I said collect, I think I probably meant collect and interpret.
Yep.
Yes. Now, if you go to page 17 of your report, this report, you say there at line 646, in the middle of your screen, you say it's page 17, yes, 646. You say the education and training structure of the fire and rescue services is consistent with professional practice. Nevertheless, the view that dominates among the fire and rescue services is that their education and training should primarily contribute to the developing practical professional skills in the form of familiarity with equipment and methods and techniques to enable them to operationally handle various kinds of accidents in a confident and safe manner. Would it be right to say that in your view and in your experience of working with fire and rescue services, there is an overemphasis on the practical operational side of firefighting?
I would say that there is an underemphasis on the technical aspects of operations, and I think again this is where once again we run into the problem of definitions, and for many the definition of technical knowledge, means to know how much pressure I can put in a pipe, or means how a ladder is going to work. That's perceived many times as technical knowledge. What I perceive as technical knowledge, or the way I interpret the word technical knowledge, is more understanding the principles of how a fire behaves, and particularly the principles of how a fire behaves and interacts within the context of the environment in which they want to operate, whether it is a building or a factory or it is a forest fire. There is a need to understand those principles. And that's the part of the technical knowledge that is generally ignored. There's a perception that technical knowledge, it is being proficient with equipment.
Yes, I see. And would it flow from that your view is that there's not enough focus on technical knowledge and education required to underpin practical operations, even though that technical knowledge and education may be more theoretical, perhaps?
Well, again, the use of the word theoretical is one that I have to say I actually take offense, because it is not theoretical. And I think it is based on theory in the same way that understanding what the pressure of a pipe is based on theory. It is deeply applied knowledge that is actually used for the purpose of understanding your job. And the fact that people refuse or do not want to take that knowledge, arguing that it's theoretical, I think is a mechanism to deflect an obligation.
Yes, what didn't come across in my question, perhaps, was the inverted commas around the word theoretical.
Yes.
I'm not positing it to you as a truth, but I think I understand the answer was answered my question.
Yes.
Now, I'd like to turn next, developing this theme, to the Holmgren paper 2014. You cover this in your first phase 2 report, this one, on page 17 itself. And indeed, it's on the screen at the moment in footnotes 25, 26, and 27. And that, I think, is a paper, is this right?
Yes.
Published by Robert Holmgren in the Nordic Journal of Vocational Education and Training in 2014.
Yes.
And it considered reforms that had been made to Swedish firefighter training.
Yes.
Yes. Now, the paper is at JTO 703, and I'd like to consider some of its findings with you, Professor. There it is on the screen. We'll look at the detail in a moment, but am I right in thinking that these Swedish reforms were intended, in summary, to broaden the basic national firefighter training programme?
Yes.
That included by extending the length of the training programme from 15 weeks to 2 years.
Yes.
And giving it tertiary education status.
Absolutely.
And also, I think, supplementing previous experience-based knowledge orientation with science-based approaches and knowledge.
Yes, and the development of a fire engineering program at Lund University.
Yes, and the expression science-based approaches and knowledge is what I think I intended to convey in my use of the word theoretical in inverted commas. So I don't want to you to think that it's my view. I think this was part of a general objective, wasn't it, to develop the students' independent decision-making skills and problem-solving skills.
Yes.
And the introduction of those science-based approaches meant that academically orientated professionals, such as fire engineers, were employed to deliver part of the training.
Yes.
Yes. Now, the study that Robert Holmgren carried out, I think, involved conducting interviews with instructors, both from the operational side of the training programme, excuse me, and from the more science-based side of the programme.
Yes.
Yeah. And the purpose of that, am I right, was to explore the instructors' views about what the students should learn, why they should learn it, and whether and how those conceptions should have been affected by implementation.
Yes.
Yes. Now, and I'm really summarising for others what you already know, I think, but two trends emerged. Is this right? First, the instructors from the operational side of the training programme, or they are, as they were designated, which stands for rescue,
Yes.
tended to express the view that education should primarily contribute to developing students' practical professional skills in the form of familiarity with equipment, methods and techniques.
Yes.
Kit, in other words. Yes. And that was consistent with the observations I think you've made in your report and in your evidence just now about the approach of the LFB to the function of operational training and procedure.
Yes.
If we go to page 7 of the paper, please, we can see in the second substantive paragraph under the heading Professional Learning, it says, in this view, which dominates among fire instructors, a little bit higher up, instructor conceptions about professional learning, two dominant conceptions of professional learning are prominent among instructors. One is widely shared by the R instructors, while the other is most prevalent among the S instructors. And I think the S stood for science, doesn't it, or safety?
Yep.
Yes. It goes on in the third paragraph there, under the rubric Professional Learning. In this view, which dominates among fire instructors, are the education should primarily contribute to developing students' practical professional skills, etc. And then it goes on to enable them to operatively handle various kinds of accidents in a confident and safe manner. The practice and criteria of the rescue services are often stated as the yardstick for these skills to which training and teaching should relate. The training should, in other words, be stamped by the endeavour to educate for and adapt to the norms and criteria attributed to the professional practice of the rescue services. And then it goes on, to enable such learning, the emphasis is on teaching, dominated by quantitative training and drill-type exercises, which are considered to turn knowledge and skills into second nature and part of the muscle memory. Now, I've shown you quite a lot of that. To what extent, in your opinion, Professor, is that approach to training, the emphasis on quantitative training and muscle memory type learning, reflected in the evidence that you've seen about the way in which firefighters in the LFB were trained before the Grenfell Tower fire?
It's very strong.
Very strong. Very strong emphasis on quantitative training and muscle memory. And is that type of approach to operational training a problem?
It is a problem in the sense that that it translates upwards in the hierarchy and in the decision making, where you actually need different attributes, and fundamentally you need a different purpose and motivation. I think one of the things that people don't recognize is that one of the key elements of professional learning is purpose. When you're trying to educate a professional in a university, for example, to become a professional, the first thing that you need to make sure is that that person has a purpose. So you're not going to have a civil engineer being successful if all they wanted to be was an artist. And so there has to be that element of purpose. And so the type of individual that is recruited to conduct this type of work with this type of training is very different to the type of individual that you should be recruiting to conduct more analytical skills and more analytical jobs and more technically oriented work, because they have a different purpose. And if you don't develop that purpose, there is no way in which these individuals can reach autonomy. And at the end, what you want from a professional is that level of autonomy, and that starts with purpose. Only after that you can provide structure. So this is a well-known concept called the PASS, and it's purpose, autonomy, and structure. So if you start with individuals that have the wrong purpose, it's not about their skills, is the purpose, it's what they want to do, what they feel attuned doing. If you don't have people with the right purpose in the space of professional practice, you will get the wrong outcome.
So this is about recruitment.
So it starts at the recruitment process and is reinforced by the training and is reinforced by the practice.
Yes. Now, the second trend, I might come back to that answer, if I may, when I've thought about it a bit more, but the second trend, I think, observed in the Holmgren study, the Swedish study, was that instructors from the science-based side of the training programme, which I think was accorded an S for or safety, considered, and if we go to page 7 at the bottom of the page, you can see what's said. Among the instructors within the risk and safety area, S, the conception is that knowledge oriented towards the understanding of both actions and situations should be the education endeavour. Ready-made routines and checklists are thus discarded in favour of subject-integrated learning, which can facilitate the understanding of the complexity and the circumstances prevailing in risk and injury situations and in relation to the resources available. Now, the paper also, I think, suggests that kind of approach to training and the more drill-type approach that was favoured by the operational side of the programme are not mutually exclusive. Would you agree with that?
I think it's difficult to marry, but they're not mutually exclusive. An individual that has the right purpose could assimilate both sides.
Difficult to marry, but not mutually exclusive.
Yep.
Would you consider, therefore, that an effective recruitment and training regime needs to encompass both types of training, an element of drill type or muscle memory that fosters familiarity with procedures, with equipment, as well as an element of knowledge-oriented learning that fosters independent decision-making and understanding of risk?
Absolutely. There has to be a balance between the two that not only enables, to get the right people in the right position, but also allows for individuals who actually can do both and can migrate, from one position into the other. That will be a very effective recruitment and training process.
And the word balance in that answer is interesting. How, in practical terms, would a fire and rescue service go about balancing those skills?
Well, I tried to describe a skeleton of the concept in my report, where I said there had to be, there's three components. One is the command skills, the other one are the technical skills, and then the other ones that you described as muscle memory skills. So you have these three sets of skills, and there has to be an interaction between all three of them in a way such that they feed each other, because they're complementary in nature. They all work together at the end to deliver the objective. So they have to coexist. The problem that we have right now, and the reason why there is no balance, is because you really only have one. And that one progresses through all the ranks. And while people are acquiring managerial skills and so forth, at the end, their purpose remains the same. And therefore their inclination to put effort, attention, and assimilate the technical information or the command-related information is really not there, and therefore they're very inefficient at assimilating this type of information, while they're very efficient at assimilating the information for which they have a purpose. And this is really where the imbalance is. So what we end up is with one side, and we miss completely the other two sides.
And is this right? Would you think that could lead to structural imbalances in a fire and rescue service?
Absolutely.
Is it right that perhaps the most significant finding of the Holmgren study is that despite the move towards new programs encompassing both practical and operational and more, as it says, academic science-based learning, it was the practical operational side of the training that continued to dominate the program?
Yes.
And is it right that there was a general resistance on the part of the operational instructors, the R instructors, to accommodate the new science-based learning from S?
Yes, that is correct, and I think again, this is one of those spaces where, once again, it would be great if I could give you an explanation and an answer of why was that the case, but as you might imagine, by the fact that I got a Norwegian study, these studies are really very far between. I mean, the type of work, this type of work that really needs to be done in a very careful way is work that has never, ever been given priority. And while the Swedish experiment was an experiment that to some extent resulted in very positive outcomes, it is far from being perfect.
But nonetheless has an element of universality about it.
Absolutely.
Yes. As I think it was recorded in the conclusions on page 13, we don't need to go to them, but the S side of the programme was effectively marginalised.
Yes.
Yes. And to put it in blunt gender terms, if I may, does it appear that, as part of the findings, there was a powerful driving gender bias, male over female?
That has been recorded for many years.
And therefore, and a strong resistance to change based on established conceptions about professional learning and on teaching tradition and training structures.
Yes.
So, in a nutshell, this study, the Swedish study, is this right, found that despite an attempt at a change of direction, the male hero rescue culture, if I can put it that way, almost borrowing from Dave Bagent's 2001 article, and conservatism and resistance to change continue to dominate to the subordination of science-based, more theoretical, in inverted commas if you like, academic science-based learning, which was regarded as more female.
Yes, I think a lot of these traits were identified and recorded.
Is that type of resistance that I've just summarised based on the Holmgren paper something you observed in fire and rescue services in the United Kingdom?
Yes, and I will say it's a global.
And what about the London Fire Brigade specifically? Do you consider, from what you've seen, that there's a problem with not prioritising more academic science-based learning?
I think it's a very strong problem.
Now, Mr. Chairman, I've got 2 or 3 more questions on this before we finish the topic. When Assistant Commissioner Dan Daly came to give evidence on day 118, he was head of the LFB's Fire Safety Department, and he gave evidence to us and said that, and this was in his witness statement, that fire safety issues were not always top of the list within the brigade, and that the perception of fire safety issues, in this case, using the Shepherd's Court fire in August 2016 as an example, were, use his words, technical and geeky. Technical and geeky, he said. And also, there's a tendency for operational issues to take precedence when it comes to learning opportunities and dissemination. Is that approach that he had encapsulated consistent with your own experience and understanding of the approach to learning within fire and rescue services in this country?
Yes, I'm going to make a joke, but so ask permission. But I normally tell my students that to be able to work in an educational manner with the fire service in the UK, you have to be willing to have an endless capability to accept humiliation.
Right. That is a joke, but with an edge to it. Do you know whether this is a problem unique to the London Fire Brigade, or whether it reflects a broader trend in the United Kingdom?
No, I think it's a much broader trend, and it's not only the United Kingdom. I have worked with the opposite side when I lived in Australia with the Queensland Fire and Rescue Services, and it is exceptional when you find the opposite.
Within the LFB, as we know, there was a fire safety department, which included a fire engineering group, the members of which were qualified and in some instances were chartered fire engineers. Does it follow from what you've told us this morning and your reports that you do not consider that that level of technical expertise was reflected in LFB's training side and operational side.
It's not.
It's not. And are you able to give us any insight into why that was the case?
Well, I mean, I think it goes back to the point I was making about purpose. To be able to devote yourself to understand a problem appropriately and lift your level of professional competency, you have to have a purpose. You have to believe that that is important. And while people don't believe that that is important, that other aspects of firefighting are much, much more important, then you will never be able to acquire those technical competencies.
Looking at the events on the night of the fire, do you see parallels between the conclusions of the Holmgren study and the realities of the London Fire Brigade's response to that fire?
Very much, yes.
Mr. Chairman, that's a convenient moment. We've come to a slightly different topic.
Yes. Well, we'll stop there for some lunch then. Thank you very much. You're doing quite well, are you, with the witness?
Yes, I'm doing very well, and we will be finished well within this afternoon.
Right. In that case, I shall err on the side of generosity and say we'll come back at 2:05.
Very good.
It's time we had a break for lunch, Professor Torero. So as I say, we'll come back at 2:05. And again, please don't talk to anyone about your evidence over the break.
Thank you.
Thank you very much. Thank you very much. 2:05.